Hello and a very warm welcome and thank you for joining the BATC CAT25 Part 2. My XYL, Tammy M0TC, is just sitting off camera here, and myself are very pleased to host this event again for the BATC this year. Let's start by taking a quick look at today's programme. So in a moment, our new chairman, Gareth G4XAT, officially opens the CAT25 Convention Part 2. At 10:15, Portsdown developments. Dave G8GKQ will bring us all up to date with the latest Portsdown developments and demonstrate some of the extremely useful facilities on what is much more than a DATV transmitter. At 11 o'clock, Charles G4GUO will give his thoughts on what impact artificial intelligence will have on amateur radio and give some examples that can be used today. At 11:45, Justin G8YTZ will give an overview and insight into the repeater design of GB3JV, JT and GB300. At 12:30, an ATV packed lunch, an informal Q&A and interactive Zoom session open to you all to join. There's a link on the newsletter and will also be given on the screen, plus a look back at a wonderful ISS contact last weekend. At 1:30, Phil M0DNY will give an update on HAMTV from the ISS. At 2:15, Jen G4HIZ will tell us about a taster-receive system to receive ATV pictures from the International Space Station. And at 2:45, Phil will return to talk about why you must use filters to reduce Wi-Fi and 4G interference when receiving HAMTV. And then we'll be closing the meeting with Dave G8GKQ at 3:15. Well, if you're watching this live on Saturday the 25th of October, then you're welcome to ask questions and make comments during any of today's presentations via BATC or YouTube chat, and I'll read as many as we can have time for to each presenter. But now let's go over to the BATC chairman, Gareth G4XAT, to open the event.
Okay, morning everybody. All our members and viewers, both in the UK, Europe and worldwide even perhaps. First of all, I'd like to thank very much today's speakers and Dave and Tammy for hosting this very professional looking show. I will also add my apologies for the extraordinary skin tone that my camera has chosen to show today. It's the first time my Kaio, as you see me using on nets, has thrown this wobbly, and it makes me look like something between an Oompa Loompa and something else. But those who know me will know it's fake. Anyway, onward. Okay, this afternoon's show, I'm afraid I'm going to miss it for the second time because I've got an unavoidable previous commitment, and Dave has very kindly agreed to wrap things up at the end of the day. And not only did I miss Phil and Jen's talk at the RSGB convention, I'll have to watch it on catch up after today. So if there's anything you need to see, then it will be on the BATC YouTube channel, is my understanding. Okay, I've got a sheet of notes here to make sure I've got everything covered, and I've got a stopwatch running so I don't waffle on. I've had a very busy year, as you may have heard. Scuba diving in Gozo, which did involve some radio, a kitchen strip out and refurbishment, which was hard work, but is all nice and tidy. Extensive work on the repair, restoration and re-engineering of a 40-year-old kit car. I've had a long involvement with vehicle projects, so that was something to add to my list of things to do. Also an attempt, and I call it an attempt because I didn't manage any contacts at all in this year's IRRU ATV contest. What I would say from that is mind the trees if you want to use 10 gigahertz, and also look after your access privileges very carefully, since mine is now 50 quid a day if I want to go to that particular location, and there's nowhere else nearby that works. Okay, CAT25 Part 1 and the Saturday dinner, which sold out, was an excellent social event. And it was complemented very much by a live ISS pass, even if it was a blank raster. Thanks very much to Phil for setting up all that stuff. and also myself for bringing along the scruffy looking but functional ground station for Q000, and also Jen's much smarter solution. Okay, club membership. It's nice and stable, just under 1,400 members. And it's been very well represented by committee and members at a whole range of rallies this year. I'll read them out if I may. Norbeck, that's Blackpool. Martlesham Microwave Round Table, Dunstable Downs. Frigdischstaffen. RAL Microwave Round Table, Reading, Wimborne Hamfest, Telford Hamfest, Newark Hamfest, Hornsey Rally, RSGB Convention, and the planned Midland Microwave Round Table. Thanks to anyone who's assisted, and do please pop along and say hello if you see us there. Okay, moving on. Although Facebook is, shall we say, less than ideal these days as an environment, there is a lot of good stuff buried in amongst all the fake rubbish and distractions and advertising. And in particular, there's a BATC page where I found some really good stuff over the years. There's content there including building of equipment and stuff for sale and generation of subsequent RF put to good purpose. There's also been some interesting experiments from the European community where Filippo Francesco Alexandro Stavros and his son have been pursuing digital ATV, but mostly across the Ionian Sea between Scilly and Greece, but also within Italy itself, where they've had success on 6 meters, 77s, 23, 6 centimeters, and 3. I mentioned I took some gear to Gozo. I even built this to take for 13 SEMs because it will fit in my suitcase. In the end, that didn't happen for a variety of reasons, but I did take a 5-watt handheld, and I was very pleased to work, albeit via the Gozo repeater, Stavros on the mainland of Greece. So 700 kilometers, albeit via repeater. That was good. They have pursued and continue to pursue a variety of propagation modes, aircraft bounce, which is, well, it's interesting. If you haven't tried it, it's definitely worth a go. You don't necessarily need a tweakable in azimuth or elevation. Well, you need azimuth, but maybe not elevation. Noel and I can manage a contact on 70 SEMs, even though there's a very large hill between us. You just have to sit and wait because the aircraft come in on a nice approach on their way to Heathrow. Very conveniently about halfway. There is, of course, the Air Scout website, which will help with predictions for that. Something they've done recently, I noticed, is balloon SSTV. Okay, so it's not fast scan, but it could be fast scan. And as a result of that, it's almost interesting to wonder how else we could get a picture in the air. Has anyone got a PPL, for instance? Because we could build some nice lightweight gear. We have to be a primary user on the band to do aircraft mobile, so it's only 2 meters, I'm afraid. But if anyone fancies a crack at that, I'd be interested in joining in and progressing the hobby. Okay, let's see now. Okay, en route to the RSGB convention, I called in at the NRC at Bletchley Park, where I would say you can get a free access ticket if you're a member of the RSGB, which makes it worth joining the RSGB, apart from all the other good stuff they do for us. There's a very good display of radio through the ages and paraphernalia. There's also an excellent wideband DATV ground station receive, where passers-by can touch the touch screen and view the content. That's a very helpful little extra. Related to that, I was approached by the RSGB NRC coordinator and asked if we could possibly put up a wideband link. And I would say that is progressing. It's more likely to be something next spring or early summer, and might involve 2 ground stations such that families could actually have a DATV QSO via the satellite whilst separated by perhaps 50 yards or so on the ground. Work in progress, I think it's safe to say. Okay, onward to the conference then, which is 10 minutes up the road. A very busy Saturday. It was nice to receive praise for our CQTV, which is the work of Frank and contributors. They particularly liked the feel of the magazine, so do feel free to buy yourself the paper copy as well as the online subscription. And also please remember that students can join for free. I always found that it's not so much that people don't have an interest in electronics or DATV or Raspberry Pis or whatever. It's that these days there's so much on or available to distract them. Unless you draw their attention to it, then nothing will come of it. Okay, you may have read Radcom, and there you'll see a picture under the special interest group promoting the convention. That's last year's display. This year's display was even better with additional stuff from Dave and also Phil's ground station, which generated a lot of interest. Shows you how you can get away with something that's not too large. Okay, let's see now. Last Saturday, it was a really good ISS contact, I thought. I watched the warm-up done by Kieran and then the actual contact. And I was also watching the merger. There'll be a lot more about that this afternoon from Phil and Jen. But I think the beauty of the project is how well it promotes STEM and the contribution mathematics makes to getting things into space. And also the questions, I think, were the usual range, but some very well thought out things buried there. The link to the I've gone a bit blank there, apologies. The video link up where the stations sequentially offered up their video, that really did work well. And you got to see the warm down in the space station as well. Justin's presentation on repeaters. We've had several digital upgrades recently, which you can read about in CQTV. Those have shown the benefits of going digital. If you think you want to convert, then do think about applying for a bursary. The funds are there if the cause is just. And use your local repeater. When I was lucky enough to acquire a decent 23 cent beam, I thought I'd experiment with accessing JV and found I could actually achieve that with a barefoot Pluto. Okay, so it was a 48 element beam, but you get the idea. Okay. Right. As David mentioned, there will be a clip of the ISS link in case you missed it after the lunchtime chat. And if there's anything you wish to talk about, that's a good point to pop it in and see how things go. Time-wise, I've got about a minute or two, so I would just say enjoy the day and do please let the committee know what you think about the hobby, the future of the hobby, what we should be doing, what you think about CQTV. I know Frank regularly asks for feedback, but other than the comment I received at the RSGB convention, it's all a bit quiet. And although we could assume that if no one's saying anything, all is well, it would be nice to know. So with that, I shall hand it over and wonder what on earth was going on with my camera, because the rest of the picture looks okay. I probably won't pop back, but I'll be listening and watching until 1:30 when I will have to go. Okay, I won't say 7 threes, but I wish you all well and enjoy the rest of the day. Over to you, Dave.
Thanks very much, Gareth. Well, our first presentation comes from Dave, G8GKQ, who first transmitted amateur TV in the mid-70s, which was actually 405 line, and has kept up his interest over the years, and since retiring has increased his involvement as the lead developer on the very popular BATC Portsdown project. And he's here today to update us on the latest developments. Now, as with all of today's presentations, if you're watching this live, you are welcome to ask questions or make comments during any of today's presentations via BATC or YouTube chat, and I'll read as many as we can to the presenter. But so welcome to you, Dave.
Good morning, all, and thank you to David and Tammy for the expert hosting. I'm going to talk about the latest state of the Portsdown, which is a project still alive and well, despite the fact that we started back in 2016. I was looking at the picture on the intro slide there, and that was taken in Christmas 2016. So let's crack on. I'm going to talk about the project status, recent developments, and where I see the project going. But first of all, I thought I needed to give it some context. You know, we started this, as I said, back in 2016. The hardware video encoder that's used in the Portsdown is certainly pre-2012. So, you know, it's 13-year-old technology. And at the time we started, it was a great improvement on an analog video. You know, the standard setup then was to go into a video capture device and then straight into the Raspberry Pi, and we could get nice digital pictures out of that were really good quality. So it was the bee's knees at the time, but now I see the Portsdown as having two primary roles. A portable DATV transceiver with band viewer. So, you know, it is the go-to setup for hilltops. You don't need to mess around with a laptop. It's all in one box, and it gives you the additional facility to see what the spectrum, look at the spectrum on the band. And we'll talk about that a bit more later. In the shack, though, it's been eclipsed by graphics cards in high-end PCs. It certainly can't encode H.265, and it struggles with high-definition H.264. And for that, the shack PC is probably best. But where it does come into its own in the shack is the test equipment capabilities. So that we continue to develop in that area. The Portsdown 2020 is the direct descendant of the original version we started with in 2016. It works with the old 3.5-inch touchscreen that clips onto the GPIO, or on the newer Raspberry Pi 7-inch touchscreen. We continue to support this with its current functionality. Just to let you know how much support, I control my transmissions to QO100 using a Portsdown 2020, and I have two others sat in the shack here, which get pulled out occasionally to do things. So very much still supported. I haven't yet put in the mod for Pico Tuner. Nobody has asked for it. It will work as a receiver with Mini Tuner. And, you know, if you don't update it, don't connect it to the internet, it will live on forever, effectively. But all the software in it is getting a little old and creaky, so it's not really fit for update. Portsdown 4 is currently the best fielded capability. Now, you can either use a Raspberry Pi 4 with a touchscreen, or you can control it from the web interface. You just point your web browser at the IP address of the Portsdown. That's particularly useful if you're doing any testing out in the garden with a dish or something, in that you can get it on your smartphone and look at the test equipment or the receiver on your smartphone to pick up a dish. You don't have to drag all the kit outside. It does, of course, support Pico Tuner, and the test equipment continues to be developed. So if anybody wants to know what to build today, I still recommend build a Portsdown 4. Portsdown 5. Now, the Raspberry Pi 5 was introduced about 2 years ago, and everybody said, oh, great, we can upgrade Portsdown and so on. So we've been trying. Uses a 7-inch touchscreen or an HDMI screen with a mouse. That's a new development I put in there. So instead of having a 7-inch touchscreen, if you want to use it in the shack, you can plug an HDMI screen in and a mouse. Or you can do it through the web browser as before. It's very much still under development. The major problem is it doesn't transmit reliably. And the reason for that is we can't get access to the hardware video encoder that we've been using on the Portsdown 4 or Portsdown 2020 because they've written it out of the operating system. So we've tried software encoding and haven't really yet found the right incantation for FFmpeg to make it work reliably for digital ATV at low bandwidths. However, what I will say is I've now got to the stage where I have a stable build that if people want to play with a Raspberry Pi 5 and the latest operating system and a touchscreen or an HDMI screen, I've formally released Portsdown 5 today. I know a couple of the builds over the last couple of weeks have been actually not quite up to standard, but I'm aiming to keep something that will build properly as of today. So let's go back to the Portsdown 4 and talk about what's been going on that. I've looked back over the changelog for the last year, and really a lot of it is just minor bug fixes, just sorting out little corners of the envelope where people have said, yeah, it doesn't work properly here, and I've been sorting out that. The other problem I have is over time, software developers update their software. They do aim for compatibility, but inevitably odd things break, and I need to introduce workarounds for that. But at the moment, we're up and running and full functionality on the Portsdown 4. One thing I have to thank Gareth for is we're now able to use the Pluto as a transmitter all the way up to 6 gigs, so we can cover the 5.7 gig band. The issue with that used to be that every first cut of the firmware for the Pluto, the special firmware you need to use with Portsdown, had an overflow of the 32-bit number, 32-bit number at 4.2 gigs and would not transmit above 4.2. Gareth managed to find that there is actually another subsequent release where Everest has fixed that bug, and the details of that release are on the wiki. You can download it from our wiki, and the Portsdown software now will accept that firmware. So that's a capability improvement in the last couple of months. The other thing I've done is added support for the HAMTV merger. Now you'll hear a lot more about the merger this afternoon, but I wanted to show you how easy it is to contribute to the merger if you're receiving HAMTV using your Portsdown. I added an extra menu. You can get to this through menu 3. And it's just another receive menu with a few extra buttons. The top 3 buttons there are straightforward, what frequency, because some people use down converters, I certainly do. What input on the LNB, and whether you want LNB volts on if you're using one of the smart mini tuners that has a LNB voltage output. You then just need to set your call, the pass key that's given to you by Phil to connect to the merger, and what region you're operating in. Eventually, we hope to have servers around the world for this. The region Europe is the one we use here, or you can select on that button the test server for initial tests. And then you just press connect to merger. That connects you to the merger, and you should see yourself come up on the merger web page like this. You can see the second one down there is myself during the last contact. That button goes online. You then just press receive, and the merger does the rest. You see the normal pictures as you would normally on your Portsdown screen, but it is also uplinking to the merger. Nothing more you have to do. And this was the merger during the contact last Saturday. You'll see a lot more of that later, so I won't go on. But I believe, I don't think who else was using it. There was one other station using the Portsdown for the uplink, so that's been used. The other thing I've been looking at for a while is the Muntjac. Some of you will have heard, in fact, Brian wrote a CQ-TV article about it. Transmit SDR using the same hardware, the same chip as the Caribou. Now, the Caribou was an SDR that was, I think, crowdfunded couple of years ago, but the software support, as often with these crowdfunded things, didn't match the hardware aspirations, and I think many people got very frustrated with it. But Brian G4EWJ was clever enough to realize that actually the chip used could be used for DATV and could be paired up with the RP2040. Now, the RP2040 is the same chip as is used in the Raspberry Pi Pico microcontroller. Very easy to program and very capable. The hardware SDR transmitter only covers 70 SEM and 13 SEM, but actually, those are the 2 bands that a lot of us really need, in that certainly all my portable kit, portable microwave kit, I up convert from 70 SEMs. And 13 SEM, of course, that gives you the QO100 uplink. Now, it's quite a small PCB. For an idea of size, you can see those, the edge connector on the top there is 0.1 inch pitch. So it just fits, it will fit on top of a Raspberry Pi, and it just takes the power from the Raspberry Pi when you do that. You connect USB to the right-hand end there and plug into the USB connector on the Raspberry Pi. And from the output to output, where you'd normally select Lime, Pluto, or whatever on the Portsdown, you just select Muntjac, and it transmits seamlessly from the Portsdown. Now, I was having discussions yesterday about when we hope to get this out. I would hope that we're able to make hardware available in early 2026. first half of 2026. So looking very positive, and we're aiming to keep the cost down, because clearly we have other SDRs such as the Libra SDR that are competitive on cost as well. But sub £100 is very much our target on this. Now the test equipment. This is where certainly my Portsdown gets most of its use. I will go through them in a bit more detail in a moment, but there's the band viewer, which gives you a view of up to 50 megs of spectrum if you're using a Pluto, 20 megs on a line. The noise figure meter, that's reduced the boat anchor count in my shack markedly, in that I used to have a noise figure meter that was tricky to lift, let alone fit on the bench. And now the Portsdown has taken over from that, and I have moved the noise meter, the hardware meter on. Noise meter, I'll talk about how you can use that to help in your ISS reception in a moment. And don't forget the signal generator, which went in there an awful long time ago. But if you've got a Portsdown sat on the bench with a Lime or a Pluto or even a DATV Express, you've also got a signal generator sat on the bench. And of course, put CQTV articles out about how you can make it into a power meter or even a remote display for a digital multimeter. Let's talk a bit about the noise meter, because this is the one I've probably used most often, most recently. There's a lot going on this screen, but I think it's worth looking at. Top left there is the spectrum you're looking at. Now, it's actually here tuned to 731 megs, which is the IF I use for HAMTV reception. Beneath that, you can see the bandwidth I'm looking at and the noise levels. 41 dBs at the moment, and I'd set a baseline at 44. Top right is just an analog meter type, an analog type meter display of what the noise is. As with all the meter scales on Portsdown kit, you can actually touch the scale to increase or decrease the scale. It's not very obvious, not very well signposted perhaps, but if you're looking at one of the analog meter scales in Portsdown, if you just tap the scale, it changes the scale and gives you a better view or a worse view if you're going the wrong way. Now beneath that is a time plot of the noise. Now I had set up my HAMTV dish in the garden, and initially I pointed it at cold sky, and then I pressed the establish baseline button. There's two buttons there. Set baseline is where you numerically set the baseline. The button that's currently green on that display, when it's not green, it says establish baseline. You press that and it averages the noise over about a second and says, okay, that's my baseline. So if you point the dish at cold sky for that, I then said to the tracking program, point the dish at the ISS, at the sun, and to measure sun noise. Then I moved the dish off in azimuth. And that's where the plot starts on the left-hand side, looking at cold sky next to where the sun is. And I then said, okay, let's sweep right through the sun. And you can see as the rotator moved to the right through the sun, it went up to a peak of about 2.8, 2.7, something like that there, and then went down the other side. And I then said, okay, track the sun again. So it went back to the sun. And then you can see the constant sun noise there, but with Wi-Fi interference that I haven't yet completely eliminated. But and Phil will talk more about that this afternoon. But you can see the peak as I went through the sun was pretty close to the base, the tracking peak. And this gives you a really good indication that you've sorted out your dish pointing correctly. And clearly you repeat the process in elevation. So that time plot there gives you a good indication of what's going on. So there's quite a lot going on that screen, but it's really worthwhile using. And as I said, you can use this from the web view. And when I go out actually to the dish to do the course alignment outside, I just take my iPhone out there and look at this screen on the iPhone. Band viewer. This probably is the thing routinely most used. And again, here I am looking at a substitute signal, a local signal on the ISS frequency. And one of the reasons for doing this is to look at the interference. And there out to the right-hand side, you can see a Wi-Fi peak. That's local Wi-Fi interference. But this is in 50 meg span and working very well. On Lime SDR, you can only get to about 20 meg span, but Pluto gives you the 50. Often forgotten now because it was released so long ago is the Portsdown signal generator. Now, if you've got a Portsdown sat on your test bench and it's got a Pluto or a Lime or a DATV Express or even an ADF 4351 on the old Portsdown 2020 connected, you can generate signals throughout the passband of that SDR device with an approximate calibration. So really useful for testing PAs and general test around the shack. So that was Portsdown 4. Still lots of test equipment there, and I'm always looking for new ideas of what we can do. One of the things I have been thinking about is, can we do a sweep generator using just the SDR without the need for a power meter as well? And some thoughts going on to that at the moment. Let's move on to Portsdown 5. As I said, it uses the latest Raspberry Pi OS. Now, the Raspberry Pi introduced it with a 64-bit operating system 2 years ago, and they've recently updated that to Trixie, I think about 5 weeks ago. And I was waiting for this release before I did the formal release of Portsdown 5 because I didn't see the point in making two jumps, if you know what I mean. So you can load the latest Trixie operating system, the 64-bit Lite version, onto an SD card and build the latest Portsdown 5. Now, it does work on either a Raspberry Pi 4 or a Raspberry Pi 5. I have it running on both, and I haven't really noticed any limitations on the 4 yet, although I do dual development on the 5. So do let me know if something isn't working properly on a 4 or if you try it. I have rewritten the software extensively from the Portsdown 4. As you develop software, you go through this phase where, well, I wouldn't be doing it this way if I started it now. And I really wanted to reset back to, well, I'd like to do it this way, so I will do it this way. So things are internally are quite different. Externally looks fairly similar, but I'll show you a few of some of the differences in a minute. The new feature I brought in is you can use an HDMI screen with a mouse plugged into the Portsdown to control it. Now, the advantage this gives you over web view is if you're using test gear, it gives you the real-time frame update. So if you can see things on Spectrum without the 1 second jumps, it keeps on going round and round. Let's look at a couple of the new features. As we're all using larger screens now, the 7-inch screen, I put in an extra row of buttons on the menu. That's the main menu. Still, some of the buttons are probably going to be changed, but it gives you an extra line, so you can go straight to the band view or the test equipment from the bottom line. And there's a shutdown button on the front page as well. The keyboard. I don't know about you, but I get frustrated by keyboards that don't have a delete at the current position key. I only had a backspace key before, so we had backspace at top right. I've added a delete key down the bottom there. Also, you can move the cursor by touching where you want it to go in the top line there. Just makes editing things a lot easier. Now, other people probably don't edit things on this keyboard very much, but in building SD cards and so on, I do. So those features went in and may in due course get taken back into Portsdown 4. Depends how I feel about that. So what works in Portsdown 5? Well, receive works very well with either the Pico tuner or the mini tuner. Doesn't look much different from Portsdown 4 on receive. Except that I put in a receive diagnostic display. And again, this is, the old test equipment estimate emphasis. So with the test equipment, the receiver diagnostic display, you can get this screen up. Clearly, we're limited on screen space. Displaying a picture and a constellation on a little touch screen isn't really practical. So I've pulled out the constellation data that's used in the PC version of Minitune, and you can now display it on Portsdown here on this diagnostic screen. That's QPSK, but you can equally, you can display 32 APSK on there and get all the nice little dots all around the display. Now, most people just look at that and say, yeah, okay, I can see a constellation. But that in itself is another piece of test equipment, in that there you can see we've got 4 sort of fairly uniform areas of noise. And this, in fact, you'll note is the QR100 beacon at about 9 dB MER. But if your local oscillator, either on transmit, on something you're looking at, or on receive, has got phase noise on it, you notice that phase noise because the noise is more axial. It goes around the origin rather than amplitude going distance in and out of the origin. So I put in calculations there to actually quantify the amount of noise that comes from amplitude noise and the amount of noise that comes from phase noise. Now, if you've got good local oscillators, these should be the same. But certainly on my 24 gigs kit, which is a bit challenged with phase noise, the 2 figures are different. And now I've put a number on it, you can make changes and actually optimize it. So again, more test equipment. The other thing on there is a figure that measures how many null packets you have, how much headroom you've got in the transport stream. I'm not convinced of the accuracy of that figure because it doesn't agree with other test equipment. However, it gives you a relative indication. So a bit more on the test equipment side there. Stream viewer. Somebody, it was Phil actually, G8XTW asked for a stream viewer with 20 presets. Well, we've got more buttons, so yes. So there we go, the stream viewer with 20 presets. Now, I've got 2 buttons there for play. And this highlights one of the problems with the new operating system and VLC. VLC seems to have a mind of its own as to whether it will invert the picture or not with the new operating system. For H.264, it will on some pictures and won't on others. For H.265, it won't on any. So if your touchscreen is upside down, like most of us have mounted our touchscreens. If you try and play with VLC, in some cases you get an upside down picture. So I've also put an alternative player on there for the streamer, FF Play, which works perfectly adequately and gives you a picture the right way up every time. So test equipment, again, my main emphasis. Lime SDR, band viewer, noise figure meter, and noise meter are all in there now. I've concentrated on Lime because that is the thing I have most of. Pluto will come in due course. I spent the last couple of days getting SDR Play band viewer working. Now, this is really to make sure we have an alternative in the future for the Meteor beacon receivers. All the Meteor beacon receivers that are deployed currently for the 50 meg beacon are actually Portsdown receivers. And at some stage we will probably have to upgrade those to Trixie. So I wanted to get the SDR Play series of SDRs working. And lastly, the signal generator is in there for Lime SDR and DATV Express. Again, not Pluto yet. I mentioned about the VLC image orientation problem. Hopefully people will sort that out in due course. It's far beyond me to sort it out. And of course, video encoding is difficult. I will do some more work on that in due course, but I needed to have a stable platform before I could move that on. Progress is slow, just because it's a bit like wading through treacle to some extent, but I really would like to get Portsdown 5 to be as good as Portsdown 4. Okay, I'll talk briefly about some other things, and this will give you some insight as to why I've developed Portsdown 5 in the way I have. The Lime Microsystems, we've long supported their range of SDRs. They have brought out a new LimeNet Micro. Now, the original LimeNet Micro was based on a Raspberry Pi 3. The newer one is based on a Raspberry Pi 4 compute module, or even a Raspberry Pi 5 compute module. They're interchangeable on it. And the new Lime XTRX. Now, this has got a PCIe interface on it, different interface, it's not USB. And it uses a new set of Lime Suite drivers, Lime Suite NG, next generation or something they call it, which need the 64-bit operating system of Trixie. Now, those drivers are included in Portsdown 5. They're not active at the moment. I did some work on them, but I need to revisit it. The LimeNet Micro DE looks like this, a very pretty piece of RF hardware. You can see in the center there, the green bit is the compute module, the compute module 4. It's got a couple of HDMI interfaces on the left-hand side and USB and network at the top. It's 12-volt powered. It's got an onboard GPS receiver. It's got 2 receive preamps and 2 transmit driver amps. So it's more sensitive than a barefoot SDR. You can see the UFL wires that take the outputs to those preamps and the inputs to the drivers to the SDR there. And has 2 channels. And I did get some of the basics of the Portsdown transmitter working with this, and I will go back to do some more work on it. They are reasonably expensive. I don't, if you want something really good for your test bench to test mobile phones, that's what you should use. But for amateur use, it will be good to develop amateur applications for it, but I don't see it being bought by many purchasers. The other big project, the hardware project that's occupied me for most of the year, is a spectrum analyzer IF using a Lime SDR. Now, this is what I've come up with. Looks very pretty in the box. Underneath the lid, it's all a bit crammed in. But I was lucky enough to get hold of an HP spectrum analyzer, an HP H8565A, that somebody had tried to fix the front panel switches on after they broke, like front panel switches do break on older HP analyzers. And the project had clearly been abandoned. The front panel wasn't with what I bought, but all the guts were. The basic spectrum analyzer went up to 22 gigs. And I worked out that with a bit of jiggery pokery, I could extend that up to 25 gigs because, of course, I wanted to look at 24 gigs. And, well, why use an analog IF when you could put a Lime SDR on the IF? And why have a CRT when you can put a Raspberry Pi 5 and a touchscreen? And once you've got that in there, of course, you've got the Portsdown signal generator, noise figure meter, and with some extra hardware, you can build a tracking generator in there as well. So that's what I did. Sort of thing I've done here, you see how you can use an external tracking generator with it to build a sweeper from 20 to 25 gigs. At the top there is the basic attenuator with a switched attenuator on the, basic analyzer with a switched attenuator on the front, a Yig-tuned filter, harmonic mixer. It has a Yig swept oscillator there, and it uses the fifth harmonic of that oscillator. And then it goes into the IF that's based on the Lime SDR and the Portsdown software. But you can feed that swept oscillator out, multiply it by 5, mix it with the IF frequency, and with some amplification, put it through the filter that you're testing and back into the input to the analyzer. So that's what it looks like, using some old modules that came out of some DMC kit. So the local oscillator comes in at the top right there, is multiplied by 5, goes through a bit of waveguide, you can see at the right-hand side, through a couple of amplifiers, into a mixer. It's got an ADF 4351 to generate the local oscillator signal, and out the left-hand side. And this is the sort of thing it'll do for you. You can sweep this is a 23 gig filter that sadly won't tune up to 24 gigs, but you can see the response of the filter there. And it enables you to try and move filters up to 24 gigs from surplus gear. So that's what's been keeping me busy and interested, in that this analyzer has driven me migrating a lot of the test gear from the Raspberry Pi 4 environment onto Raspberry Pi 5, and then now that's gone into Portsdown 5. So in summary, the Portsdown project is still very active. I'm still adding features to the Portsdown 4 and investigating new capabilities for the Portsdown 5. Now, if you have your own ideas for something you would like to see in the Portsdown 4 or Portsdown 5, please do post it on the forum. I'm actively looking for new ideas for it. Things you think are practical. If you can think how to mechanize it, that's even better because it saves me some work. But I'm more than happy to do that. For the foreseeable future, Portsdown 4 will remain the best transmitter. Portsdown 5 transmitter capabilities, not exciting. However, on the test equipment front, I think there is quite a lot of mileage there using the extra computing power. So that's a run through of where we are on Portsdown, and I'm more than happy to take questions and expand on anything anybody wants now. Thank you very much.
Thank you very much, Dave. Whatever do you do in your spare time?
I wish I had some.
Yeah, exactly. Now, this might be an opportunity as well, apart from asking you at home. We haven't really got any questions for you specifically yet. We've only got a few minutes as well. But if you have got any questions you want to ask Dave now, then please do put them onto the chat on either BATC or YouTube. We'll get through as many as we can. But thank you, Dave. This is an opportunity, a great opportunity, I think, just to thank you on behalf of the whole of the BATC community for all the work that goes into that amazing project.
Yeah, well, it's so much good fun doing it. When I can get a piece of a boat anchor off the bench and come up with a newer, better capability, that really makes it all worthwhile.
Yeah, no, it will be very good. So we haven't got any specific questions. I've got Simon G4ELI who says he's watching with interest, but George the Spaniel not so interested. So I reckon he's probably on the dog and bone, maybe. Anyway,
absolutely.
Just a thought. So we only do have a couple of minutes with you now. Can I just, thinking that as well as many BATC members who have followed the journey of Portsdown over the last few years, there may be people watching today for the very first time just vaguely interested in this new subject, amateur TV, which has moved on a lot. So in a couple of minutes, can you just go over, for the very basics, what Portsdown is about, right from the beginning, just the basics of what it does and the project, and obviously you've explained where it's going now, but just for somebody watching for the first time.
Okay, well, it is a DATV, digital ATV transmitter and receiver in a box. And the idea was to have something that you could take out onto a hilltop and it would produce a low-level digital ATV signal for transmit and provide the basis of a receiver all in one box. So you can put it in a rucksack and take it up to a hilltop with a small PA without the need for a PC. And I think the beauty of it for me is you just turn it on, press the button, and it works. There isn't a problem with Windows Update having changed your audio drivers. You don't have to do any tweaking. Once you've connected the output of your SDR to a power amplifier and connected the power amplifier to the aerial, it works and gives you that basic entry-level capability to digital ATV. And people sometimes could be worried about the software aspect of it. Oh, I don't play with Raspberry Pi. No, you don't need to worry about the software at all. You can buy an SD card in the BATC shop. £11 isn't going to break the bank for an SD card, and just plug it in. And the rest of it is just wiring, simple wiring.
Wonderful.
So
yeah, well,
that's where we're coming from.
Thanks, Dave. No, it's a really good summary. Thank you very much for that. I have got a couple of questions. I'm not sure we're going to get them in because I really don't want to start. If we start the day behind, then we're going to have problems later on. So very, very quickly, if you could, in a couple of moments. From Michael EA7KIR, with respect to video encoding, have you tried it with Trixie from Debian.org?
No, I haven't. No, to keep things simple, we've stuck with the Raspberry Pi OS Trixie, just to keep it simple. Brilliant,
thank you. And finally, the question from Mike G0MJW from QO100 chat for Dave. With respect. Oh no, I see. That is the same question actually. Sorry, he's referring because Mike is. Should we say setting up a QSO on QO100?
Yeah, Mike and I have contact on QO100. It's giving me very good pictures actually. So well, yes,
we're looking at about 6 computers and 6 screens here. I think that's enough. So I won't be monitoring that as well. But if you do have a question, pop them onto BATC or YouTube chat. Thank you very much for this talk, Dave. That's really, and again, once again, for all the work you do for the club and particularly on Portsdown. Thank you.
Thank you very much. Thank you.
Coming up next, AI for amateur radio with Charles G4GUO. Welcome back. Our next presenter is Charles G4GUO, who was actually introduced into the world of ATV at university by Dave. He was active on the original 70SEMS analog TV in the late 70s and 80s with the well-known Worthing Group, and then re-established interest again with digital ATV, first with DATV Express and then the BATC NUCA DVB-T project. But today he's here to share how he uses AI in this hobby, how useful it is now and where he thinks it's heading. Don't forget your questions and comments on the chats during his talk. Welcome, Charles.
Oh, welcome, Dave, and thank you very much for the introduction. Hopefully this will be of some interest to people, and it's the reason I haven't been too active on amateur radio recently is the arrival of artificial intelligence. Now, what I intend talking about is just my own journey into artificial intelligence and what I think may happen in the future. So we'll move on to the first slide, hopefully. Whoops. Right. In the beginning, I bought a book on CUDA because I wanted to accelerate software-defined radio, and using parallel processing seemed to be a way to do it. That was back in the days when video cards weren't that powerful. So the first thing I learned about was how CUDA kernels work and the different types of memory in a GPU. The type of memory is the most important thing to understand. Originally, you actually had to do it all manually in the first versions of CUDA. You had to actually, when you needed to put memory onto the GPU for processing, you actually had to do a mem copy, or the equivalent of mem copy the data onto the computer, onto the GPU, I should say. The latest versions of CUDA, they have managed memory, and it does it for you. When you want to use some memory on the GPU, it knows that it needs to transfer it from the CPU and does it transparently. But actually, to do artificial intelligence these days, you don't need to do any of that stuff. The next project I tried was LDBC code decoding. That's the error correction scheme that's used in DBVS2. It's very computationally expensive, and normally it's done in specialized chips inside the receivers. But using a GPU to do it is not that a great idea. The work came from a university in Sweden where they'd done something similar, and the problem is there's an awful lot of latency, and you can do error correcting on gigabits per second of data using a GPU, but it's the latency really kills it. And then the next thing I tried was with the CUDA FFT library. I thought, oh, this will speed things up, but it doesn't really, because again, moving data from the CPU onto the GPU is the slow part. And FFTW, you know, the FFT program that's supposed to be the fastest in the West, that the performance of that is not that much difference for the type of applications that we want to use. Okay, and then along came AI. This is actually quite an amusing story. One of my relatives' girlfriend was about to start a PhD in AI, and I was talking to her, and I was saying, oh, I said, AI's been around for ages, and it's always been the promise of tomorrow. And I think you're wasting your time. And she put me right on that. So anyway, right. Well, I first started off the normal thing, learning about perceptrons or perceptrons. They're the very basic neural engine type thing. It looks like a human brain or a brain cell, and they're very, very simple. And that's the sort of page one of the book when you're trying to learn this stuff. And then that's obviously followed by deep neural nets, whereas when you've got multiple layers of these things all talking to one another. And then back propagation is the way they update the model. It uses a version of the chain rule in differential calculus for those mathematicians out there. But when you're trying to learn this stuff, most of the books, they start off with basic mathematical processing of things like grouping, curve fitting and grouping things into clusters and stuff like that. And it's not always that interesting. It's a bit tedious. So you tend to skip through the books. Well, that's the temptation. But I tried to resist that and actually read all these chapters, and I can't remember any of them now. But anyway, I even did some free education with NVIDIA. They were doing a training course for the Jetson Nano, and it's a multiple choice question, as you go through all the lectures, and at the end, if you get above a certain number, they send you a certificate. And so that's my only qualification in artificial intelligence. Right, my first project, I thought, well, let's try some transfer learning. This is where you take a model that's been trained on something else. In this case, it was a model called MobileNet or MobileNet 2, version 2, to use the American pronunciation. And it's originally designed to detect objects like cars, pedestrians, computers, rabbits, cats. It's just a general purpose object identification algorithm, mainly based on what's called a convolutional network, which is just a way of doing the process. It's similar to convolution used in signal processing. The idea is the same, but it's all done in little boxes and what have you. And then, as I said, you use transfer learning, and the way that works is that in this particular case, you created a directory with a load of directories with the objects you wanted to train on, and then you put pictures of the various items in each of the or thousands of pictures in each of the folders, and then you start the training algorithm, and it goes around and it retrains the top layers of the model to actually recognize these objects. Now, after an awful lot of effort, I did actually get something working. Now, this is QO100, and it's been trained on obviously a spectrogram of the received signals, and you can see that it doesn't get it all right, but it gets some of it right. And I think there was about 1,000 or so training samples on this, and it was all done by me by hand, and as you see, manually trained. And the training consisted of taking my cursor, selecting a piece of the spectrum, and then labeling it, saying what it was. And it's very, very time consuming. It's like that's the biggest problem with artificial intelligence, is getting enough data to do the training. So that worked reasonably well on QO100, but when I tried it on an HF signal, it didn't work at all. Well, it sort of worked in that it had never seen an AM signal before, and it thought it was an SSB signal, which to a certain extent it is. But I think this is the 40 meter band, with the top end of it at the bottom being the broadcast part of the band. But to fix this, obviously not enough training data was available, and rather than do it manually, you want to probably use something like GNU Radio to generate waveforms and then put them through channel simulators and totally automate it. So it literally generates tens of thousands of training samples. But artificial intelligence may not be the best approach to this. It may be better to use some of the classical things like looking at the width of each of the individual signals and the amount of amplitude variation across the signals and phase alterations and stuff like that. But that's pretty much where I lost interest in doing this. The next thing I tried was combining radio and speech to text. There's models like Whisper from OpenAI, which are open weight in that you can incorporate them in your own code. And they'll turn human speech into text. They can also translate between languages, so they're quite useful if you're trying to translate some foreign languages. So I tried two different ideas. The first was simply to pipe audio from a receiver, a standard amateur receiver, into a sound card and let Whisper do its thing. I tested that on a Russian language AM broadcast on HF because I don't know any Russian. And as you can imagine, it was mainly talking about what's been going on in Europe recently. I also tried it on some of there's a load of, I believe, Russian pirates that operate above the 80-meter band, and I tried it out on them. And they seem to be, either the conversations were mainly swear words and various people boasting as to how good their homemade alcohol was and stuff like that. So it was quite interesting, to say the least. The next thing I did was to connect GNU Radio to Whisper. So I just piped it out of GNU Radio straight into Whisper. And this time it was on listening to NBFM, which is much easier to do. And it's, apart from knowing it worked, I guess you could use it for listening for rare CQ calls on 2-meter FM, or when I was first licensed, the 2-meter band was alive from end to end. I mean, these days there's nobody on it. Well, I never hear anybody on it. But there are some problems with using something like Whisper, which is really designed for general conversation and long conversation, in that it doesn't like short overs because it can't build up enough history to work out what's being said. And it doesn't really like amateur radio call signs either, because it's never seen them in its training data. So it struggles with that. So the lessons I learned, with SSB, obviously you need to have some form of frequency offset correction, because it needs to be fairly close, within a few hundred hertz of the correct frequency. And you also need to do pre-processing to get rid of some of the interference. I asked ChatGPT how to fix the issue of the amateur radio call signs, and it came up with a number of ideas. One of the ideas was just simply to pre-process the text coming out, and when it sees something like G4, GUO as 3 different words, sticking them together as a call sign. And I also asked it, is Whisper a large language model? And it said no, it's not. It then went on to describe in very great detail how it works. Basically, it takes a load of spectrograms of what it's doing, and then using the trained data, it tries to match them, and that's how it does its decoding. So I also then asked it whether you could fine-tune Whisper for this type of thing, and it said no, but it also did tell me that there's some unofficial forks which can be partially fine-tuned. Right, the next project I tried, and I demonstrated this a while ago on the QL100 net, was to actually add subtitles to the TV picture. I must admit, it was just a gimmick more than anything else. I'm not really quite sure why anybody would want to actually add subtitles, other than, well, I find subtitles annoying on YouTube, so sticking them on my own transmissions is probably not that great an idea. The way I did it is you can put a text box using OBS that reads from a file and then just keep overwriting that file from the Whisper program. And this was an example of the output. This is me a few years ago. And in the same room as I am at the moment, but with a load of boxes, camera boxes actually, that's on the back. But Reeve was trained on American spelling, so as you can see, it can't spell color and things like that. But that's neither here nor there. Other ideas I had about this, well, you can clone your own voice, you can clone someone else's voice for that matter. So you can maybe have a chatbot on 2 meters, and so people think you're talking to you when you're not. And another idea I had, which I think is cheating, would be if you're DXing, you could take your voice, turn it into text, and then turn the text into someone else's voice that's more appealing for pilot operation. I'll leave that to the imagination. Right, now, the latest topic, of course, everybody's talking about since the advent of ChatGPTs is large language models. So what can we do with those? I have had a few ideas and tried a few things. Now, the first project I tried was to use it to write Verilog code. I thought, well, it's probably been trained on Python and C and Rust and all those other strange languages. Let's try something it's not that likely to actually seen that much. So I got it to generate an I2C controller in Verilog. In fact, this is the actual board. It's a FPGA, some outputs, and a GPS receiver and a serial port, which is I'm doing that for a project which if I don't have time for, I'll discuss later. Now, what happened? The code didn't work. So I tried asking it 4 or 5 times with exactly the same prompt to generate the Verilog code. Each time it generated a different version of the program. Eventually, I found a version of the program that I could understand and correct. So I sort of got it to do Verilog. If you ask it to do something simple like a down counter or something like that, easy peasy. It has no problems with that. But anything more sophisticated, and it struggles. The next thing I tried doing was, all right, I wonder if it knows anything about GNU Radio Companion. So I gave it a large text description, a sort of formal description, telling it exactly what I wanted it to do and how I wanted it done and what techniques to use and things like that. And I fed that into it, and it produced a GNU Radio Companion graph. I'm not quite sure. Yeah, here we go. This is what it produced. I asked it to do a multi-mode receiver for GNU Radio, and it does in fact work, except the AM part works, the wideband FM part works, the narrowband FM part works, but the 3 at the bottom, which were upper sideband, lower sideband, and CW, didn't work. So we had another go, and I thought, well, let's try building a GNU Radio out of tree module. So it went ahead and did that. Didn't work. I mean, it compiled and everything, but it didn't work because every time they update GNU Radio, they seem to change everything. And so I went back to my text prompt and I told it exactly what version of GNU Radio I wanted it to create for, and tried again. It worked a bit better this time, but it still wasn't really up to the job. So and it was a bit of a disappointment, but to be expected. So that's just with using, I used ChatGPT originally, but then I went on to use Claude 4.5, which is supposed to be a lot better at coding. And in fact, it is, in that the code is easier to read, it documents it better, and it generates test scripts and what have you, so that you can test the code. So I thought, right, okay, let's try something else. So the next thing I thought, well, I've got one of these Kenwood expensive radios that's got a general HF receiver in it, as well as being a handheld. And I thought, it's always difficult to program these things because they're so complicated. I thought, all right, let's try that. So I told it, tell me how to configure my handheld radio to receive. And so on, I've got a local version of well, it's GPT OSS, which is the open source version. And on that, I fed it a copy of the Kenwood manual and the question that I wanted. And it did come up with a script to tell me how to do it and how to go through the menus and what have you. But it left out one important piece of information. So I tried again on ChatGPT itself, you know, the one that you can use on the internet. And this one, that version, which is a much, much larger model, got it right. The important piece of information being that the general coverage receiver can only operate on VFOB. It won't work on VFOA. My local AI didn't know that, and it was telling me to use VFOA, so that was a fail. The next thing I tried was to configure my pfSense router, which is what I pass my internet through when it comes from the modem. And I wanted to add a VPN to it, and it was successful in telling me how to do it. Then I had a discussion with it on HF channel equalization, which is something I've been trying to sort out for many, many years. Those of you that know my history know that I did a program for decoding aircraft transmission on HF, and that required an HF channel equalizer in it. It's not the most brilliant, but I've been told of all the ones out there at the moment, it's the most successful. The most useful use for I found for AI is as a coding assistant. So you can't tell it to do, you can't do what they call vibe coding. Say, write me a website that does such and such type thing. It's not up to that when you're trying to do something more sophisticated, but it can be useful to help you, especially me and Python, in that I'm not a Python expert. I've never had to write Python in my life professionally, and now I'm retired. Obviously, I'm trying to learn it. And another thing it's useful for is summarizing documents. It might be useful for summarizing, say, Chinese data sheets for components and things like that, because a lot of the models now can actually do, they can look at images and tell you what's in images. So that's one use that might be quite good. We'll get back to the screen. Well, as I said, I haven't found it much good at vibe coding, which is the buzzword at the moment. Um, and I use it as an assistant. This is just basically what I was saying before. It's the thing to do is to generate a sort of pseudocode of what you want done, and then tell it to do to write the code for you. One example is I was trying to do a sliding window for a text window, and I thought, oh, this is going to take me lines and lines and lines of code in Python. So I told the AI to do it for me, and it did it in 5 lines of code. Now, there's no way I could have done it in 5 lines of code. But they're definitely improving. I mean, a year ago when I was trying to do this, it was the Python code it generated. It used out-of-date libraries, and it was just a mess. But these days, it's getting a lot better than that. And the ability to just highlight some code that doesn't work and say, what's wrong with this code? Or to take someone else's code and highlight it and say, can you tell me how this code works? It's definitely makes life a lot easier. Now, there are ways of improving how an AI works. I'm going to speed up, I think, because I'm coming to the end of my my allotted period. You can do prompt engineering. That's where you tell it in the prompt exactly what you give it information. Like, for example, an AI normally doesn't know what the day and date is. So in the code, the AI code I've used, in the system prompt, I actually tell it what the day, the date is, etc., who the user is, and then it knows, and it can do clever things like you can say, without giving it that information, you ask it, how many days until Saturday, and it says, I don't know. But once it knows the date it's been given that, you can say, how many days till Saturday? And it says, oh, today's Saturday, or something like that. So that's useful. And recently, Anthropic have introduced a thing called the Model Context Protocol. This allows you to actually make calls, function calls from the LLM. You give it a load of tools, and you tell it, or the protocol tells it, this tool is for searching the internet. This tool is for retrieving data. This tool is for looking at an image or something like that. And then it will actually call these tools one by one, and which makes it a lot more powerful. I use it so I can interrogate my solar power system, and also I can ask it what the temperature is and various other things. And I've used it to control GNU radio, to send commands to GNU radio to change frequency and stuff like that. So right, next we got the RAG, which is retrieval augmented generation. This is where it makes database calls, normally via an MCP call, and it can pull information that's specific to the application that you're interested in. So you could feed it, for example, it could have a database of the radios you're using and stuff like that, or frequency charts, or it just adds knowledge to a general purpose AI. And you can also fine tune the model. I've done some fine tuning. I trained a model on back copies of CQTV a few years ago, and it suddenly started to know about the BATC. But quite often you asked it who's the current chairman of the BATC, and it'll tell you who the chairman was in 1948 or something. So it's not exactly what was planned. And then finally, the latest buzzword in AI is agents, where you have these little models working in unison with one another, and models supervising other models and doing things like that. But you can generate, specialist agents using the techniques above to do particular things, and then the supervising agent says, oh, I want you to do this, I want you to do that. But at the moment, that's where all the money is as far as the industry is concerned, but I'm not convinced it's much use at the moment. Okay, you've seen that diagram. This is the outer tree module it produced. It generated the Python bit all right, and the C code it didn't quite get right, and it stuck it in the wrong place. Then I thought, well, this is about artificial intelligence. I'll ask ChatGPT what it thinks AI could be used for an amateur radio, and this is just I've just preseed the information because it produced about 5 pages of what you could do. Obviously, exam and generation from tutoring people, interference analysis, pattern recognition. I actually saw that someone on Grok was receiving interference, and they cut and pasted onto Grok, which is the AI for X, or Twitter is formerly known as. They cut and pasted a spectrogram of that and asked it what it was. And Grok came back, said, this looks like an over-the-horizon radar system, probably made by such and such, and then listed where it knew where these things were installed. So, it has been trained on that information. And I've certainly used it with Smith charts. I've shown it Smith chart and said, what's this? And it said, oh, that's a Smith chart. And I said, what's the load? And it said, oh, it looks as if it's connected to a short circuit, because I only had a short circuit, an open circuit, and a match load as examples. I haven't tried it with anything more complicated than that. The other thing it could be used for is looking for people intruding on the amateur bands, propagation prediction using information like you can get free supply sources of weather information, things like that for Tropo. Antenna design, I mean, you can use software that analyzes antennas, and you call that via MCP calls, and use real physics to check the results are okay. MCOM message handling, sorting out priority messages, is really good at analyzing and messages. Hands-free operation. There's a micro version of Whisper which will run the Raspberry Pi, which would allow you to control your radio, say if you're mobile. Smart radio data networks that knows where everybody is and works out optimum paths, etc. And how do you get started? Well, you can use the free tools, ChatGPT and Claude 4.5. The free versions of those are limited, but you can get through about one design with ChatGPT before it says you need to pay. Claude 4.5, similar thing, and you can share the work with other people. It generates a web link that you can share your work with. You can run local models on your graphics card. You really need about 16 gig of memory or more than that. Or you can run it on your CPU. And if you've got an Apple Mac, they've got a special set of instructions, MLX instructions, I think, for artificial intelligence. And quite a few of the architectures, like Olama, can cope with that. And but I mainly use GitHub Copilot and VS Code, mainly because I'm paying $100 a year to use it, so might as well. And it's an integrated environment, a bit like an editor, but you can ask the AI by doing Control-I, and it'll come up and gives you a little box, and you can either ask it a question or you can tell it to write code. And then about the most useful thing is Hugging Face, which is a website that has a load of open weight models from everything you can think of, from speech recognition, speech detection, chat bots, and all sorts of stuff, and vector algorithms for generating embeddings for searching databases and what have you. And that's it. I'm ready for any questions if there are any now.
Okay, Charles. Yeah. Well, we have a good 10 minutes left before the
that was the plan.
Absolutely, yeah, absolutely. So if you haven't already asked a question, I've seen one, or at least a comment there, which I'll read you in a moment. But then please do put them onto BATC or YouTube chat, and I'll relay them to Charles as well. Thank you very much for that overview, Charles. The thing that occurred to me most actually is at the beginning of your talk, you showed us a certificate from your NVIDIA course, which was 2019. And I mean, I think to most of us, AI, at least spoken about regularly, feels like a couple of years old. But then I and lots of others, I'm sure, watching this who sort of have an engineering mind will realise, I think, that AI is something that's actually been developed for years and years and years, really. It's just that it's now getting to a practical speed.
Fuzzy logic and things like that.
Yeah, exactly. And it's sort of just something that's got faster, so that it becomes almost immediate now, and becoming a mainstream for everybody to use. Do you agree with that?
Yeah, certainly. I mean, the conversation I had with that PhD students, I was sort of thinking, oh God, they've been at this for donkey's years and it doesn't really work that well and what have you. And but she put me straight on that.
Yeah, absolutely. Yeah, I'm a bit worried for me doing something like this actually, because I can quite see that within a year or two, and I've got some friends who still work in radio, and they're quite concerned, because at the moment, you've got newsrooms who create, journalists sit down and create news stories, and then they type them up, put them on a screen, then hand them to somebody to read. Well,
mind you, have you looked at YouTube Shorts recently? Because it's full of AI slop, and within seconds you can tell that it's computer generated and it's not a real human that's behind it, and there's just something wrong. It feels wrong.
Well, thanks, Charles. That gives me hope and confidence. But it's both clever and a bit concerning, I think, in both ways. So anyway, at home, you've got a few minutes now. If you do want to ask Charles any questions about the work that he's done, the experiments he's done, this is the time to put them onto BATC or YouTube chat, and I'll read as many as I can to him. So first up, from Michael, EA7KIR, he's got a comment for you, really. He says that I find GPTs to be helpful with Golang, I guess that is, but when I'm very, very persistent. However, its training data is out of date. That's what Michael thinks.
Yeah, that's why organizations are using things like RAG, the retrieval augmented generation, where you keep a local database of up-to-date information, and things like what I've created my own chatbot, which is based on GPT OSS 120B, but I've given it tools to search the internet. So, for example, without those tools, if you say who's the president of the United States, it says Joe Biden, because it doesn't know any better. But when it can actually search the internet, it says, oh, it's you know who. Because it can actually go out and find that up-to-date information. Another thing I found is that ChatGPT won't look at BBC website because they've got robots.txt in there to stop it sucking information out of from the BBC. But my local chatbot doesn't have any restrictions like that, and it can suck up information from virtually anywhere, even if there's a robots.chat or robots.txt file on the web page, which is just interesting. Also, mine, I've disabled it, but apparently the search library I'm using can actually search the dark web as well.
Oh, goodness me. I don't know anything about that. I don't think I want to, but I didn't know about this robots.txt either. That's fascinating. So, but who knows? It's, as I said, both fascinating, intriguing, but slightly worrying, I think, at the same time. Got one little question for you from Mike, G0LJF, who says, with people, has the Turing test been passed by AI?
Oh, that's very debatable. They now think that the Turing test is too simple.
Oh, really?
Yeah.
Oh.
They're looking at more. I mean, they're getting it to do math Olympiads and things like that now.
Well, it's fascinating. That's all the questions I've got there. But of course, just a reminder to everybody at home, there will be an open session for around about 30 minutes or so at lunchtime, which we're calling our ATV packed lunch. and you'll be able to get onto a Zoom call and then ask there. Oh, actually, I have got one other question. I'm not sure if this was meant for you because someone else answered it, but it might be meant for you. I'll quickly ask this. Can we get AI to correct lip sync, which for those of us, of course, who do a lot of this streaming and stuff and over QO100 and things, trying to align our lip sync means it's the lining up the lips moving with the sound. So do you think that's something that AI could do quite well? It feels like it should.
It could do it, but it's interesting because I was watching a YouTube channel that specializes in artificial intelligence, and they were talking about lip sync in there, and they do it manually.
Yeah, well, I must admit that's how we do it here. We've got, nowadays with digital television, we can delay or advance things to make it work. But you never know. You never know.
But I mean, one thing that they have been experimenting with is just transmitting they digitize the face at either end, and then they transmit information that tells the thing at the other end to move the mouth and things like that. And I think they can do full video, headshot type video in kilobits, sort of 2.4 kilobits or so, just by saying, the mouth is moving and things like that, and the computer at either end then moves the mouth to follow what's being said.
I've no doubt is to come. Charles, thank you so much for this insight into AI, what you found useful, a little glimpse maybe of what it's going to do in the future. Thank you very much for the talk this morning.
Pleasure.
Thank you. Next, we've got an overview of digital ATV repeater design with Justin G8YTZ coming up in a few minutes. and welcome back to CAT25 Part 2. Our next guest, Justin G8YTZ, was a BBC engineer for 12 years from 1980 and has also been involved with amateur TV since those early 80s too. In 2019, he went live with GB3JV, an all-digital ATV repeater for South East London. And although that recently lost its site, he now has new NOVs for GB3JT at Detling Hill and GB300 in Folkestone, and hopes to have a new site for GB3JV very soon. Well, today is going to give an overview of these digital repeater designs, including the new automatic logbook entry system, a design that can easily be deployed to other TV repeater using the RIDE receiver. Now, as always, if you're watching this live on Saturday the 25th of October, feel free to ask questions on the chat or wait for the informal Q&A and social in our ATV pack lunch, which comes straight afterwards at 12:30. But meantime, let's give a warm welcome to Justin. Hello, Justin.
Hello, and nice to meet everyone this morning on, still morning, isn't it, on the stream. Well, as David said, we'll go straight into the presentation. I've got a bit of a live bit at the end as well to actually show how the software works, etc. So, digital ATV designed for Kent, GB3JV, JT and 00. The site for GB3JV, as David said, was lost back in May. And we kind of have a couple of sites in mind, but I'm holding out to hopefully agree what's an absolutely fantastic site, which will give even better coverage than the old site. So if that happens, we're hoping we'll be able to do this sometime in the new year, probably Q2, maybe Q1, but more likely Q2, because the other projects are racking up as well. Since the JV design, I built the difficult parts of GB3JT and GB300, and I'll show you those in a few minutes. But software moves on, and so we've done quite a few upgrades, which GB3JV will be getting as well as a retrofit. Right now, all three repeaters at this minute are on the stream. GB300 is on my G8YTZ stream right now, but the other ones are on their own streams, and all the websites are up and running as well. Simply repeatercallsign.co.uk. Just to show you the GB3JV coverage map, what we hope it will be if we get the site we want. And as you can see, 3.4 gigahertz, some pretty impressive coverage. Should be a very strong signal indeed in that green area. The green area basically means L&B only required in a suitable location. So over to GB3JT. There's the website address up there. So this is a repeater that was located in Hastings. It's been relocated at Detling Hill in Kent. There's a 150-foot high tower that we've got access to, and the room underneath, and that will be having the new version of GB3JV design. It was actually a chance meeting at the National Radio Centre. I was on duty Saturday, and David Williams, who was the keeper of GB3JT, came in. We're talking about it, and yeah, he was looking for some help. So here I am. So some help on there. The repeater build is 80% complete. Basically, just about everything but the RF is completed. Websites, the whole lot, all the back end integration, it's all done. Network's done. And we expect to be complete with that in November. The receive antennas I've got, the transmit antenna, I'm expecting, it's in transit from Netherlands right now. I'm expecting to have that Monday or Tuesday next week. So if we can, we'll go live in Q4. It's a bit weather dependent, so it might actually move over. It's all about the antennas in that respect. And then we'll talk about the coverage quickly. Now, what's interesting, you might have noticed that the coverage gets to Gillingham, but not to Gravesend, but JV will cover Gravesend easily. And you'll notice a gap in Canterbury there. Well, that's where GB300 comes in. So GB300, it's an ex-ambulance site located near Panelsworth in Kent, which is actually the second highest point in Kent after Rootham. and it's just 3 miles northwest of Folkestone. I was actually approached by the Black Sheep contesting group to say they bought this site and would I be interested in putting a repeater on it. And so I said, think about that. I'll get you back in a couple of weeks. Or did I say, yes, straight away. Again, transmit antenna going to the top of a 100-foot tower on the second highest point in Kent. And the repeater design's an exact copy of the OO repeater, and I'll show you this in a minute because it literally is down to the last screw identical. The repeater build, of course, is 80% complete. I built it immediately after the NOV came in. And the RF sections, that's the bit that has only just started construction. TX antenna is under construction right now. Bert Moderman, who built the one for JT and JV, actually, he's prioritising the OO antenna after that. And then I've got some filters coming as well, which I need. So we're looking for go live 2026. But to be honest, the biggest delay will be getting the antenna rigged, and we have a professional rigger down there. So I think we could come forward on that. It's all down to the antenna delivery for that. And guess what? There's the coverage. So we've got Canterbury covered there, and you can probably see the 3 repeaters. If I overlaid them, which I haven't done, but if I overlaid them, we would pretty much have blanket coverage of everything north of Tunbridge Wells up to about Croydon, and then obviously into East London, etc. as well. So that's the hope. We can get some good coverage to anyone who wants to do amateur television in Kent, northwest Kent, southeast London, East London will be able to do it with a local repeater. Just going to quickly show you the controller rack. The bottom row there, you'll see the 3 Raspberry Pis in a rack mount chassis, case chassis, which I've used before from a local company. Above that, you have the networking equipment. It's a Unify UCG on the left, and on the right, PoE switch there as well. Above that, in the next silver rack, is the NUC. It's a Chinese NUC, which I've had very good success with these things before. Obviously, power distribution. And that pull-out drawer, which isn't lacking its handle right now, I've got a handle, I haven't screwed it on yet, contains the Blackmagic A10 Mini Pro and the receiver, the 2-meter receiver, talkback receiver, and above that, in that shelf there, you can see a mini tuner as well. Say the 3 Raspberry Pis are media player, stream receiver, and the 77 receiver for that. Right, network overview. So all the repeaters are networked using SD-WAN technology and Unify hardware. VPN access to the whole network, of course, directly from my home and other family homes, actually. We use Modbus TCP RTU device. It provides a remote dashboard, allowing remote shutdown and performance and alerting and monitoring, what have you, SWR and things like return loss and things like that. And all the repeaters are sat on a UPS to isolate against any short power outages, which, out in the sticks you can get this. We never had any problems like that at Petswood, but it's a very stable power around here. But we still had a UPS on that, and we never had any issues relating to power because of that. So the network, just quickly go through. That's the SD-WAN. You can see the repeaters: GB3, JT, JV. Honeywood, which is my father's house, because I look after some of his IT remotely. My house at Lewiston, which is a bit more complicated. It's the UDM Pro Unify in there. Newlands, which is my daughter's new house, which has been another project from in last year. And then GB300 at the bottom. So that's the network. And if we just look at one particular, I think that's GB3JT, that one. Yes, it is, it's JT. You can see the firewall there and the devices on that network. We can look at those live later on. And not forgetting telephony. So I found it very useful to have a landline at these sites, and I've got an Asterisk server at home. So I've bought a couple of new old stock obsolete SNOM 320s to put down there, and that's working very well. So we've got the whole family on an internal phone system as well. and the repeater sites. So we talk about the receivers now. So I'm rushing through this bit because I want to spend a bit more time on the live part. So the RF and stream receivers are modified ride with mini tuner in the case of the RF receiver. The 77 receiver chains the big wheel antenna, interdigital filter after that, preamplifier, and a SAW filter and the mini tuner. And that has been a superbly well engineered receive system. Even the noise of southeast London found it very successful. The SAW filter is very successful at getting rid of commercial television and, in our case, Crystal Palace, which is an enormous signal off the big wheel, 9 miles as the crow flies, on top of a tower at one end and a high building at the other end. Stream receiver, again, is a modified ride. I'll talk about the modifications later. And a talkback receiver is a QIT KTWP12. Now, if you've not seen these, they're a little die-cast box, about smaller than a Nook, actually, a little bit bigger than a Raspberry Pi in a case. And they're pretty good. And the great thing about them is they haven't got a front panel. It's just a die-cast box. And everything's done through the speaker mic, and there's a screen on the speaker mic and the buttons, etc. But of course, what it does do is it gives you a line output audio from the microphone connector, and that's very useful for feeding into the ATEM, one of the ATEM's analog inputs. In the design, we have a 2-meter receivers, Diamond X30, interdigital filter, preamp, SAW filter, same arrangement. And we've allowed in the design for a second stream receiver to support networking of 3 repeaters, or another, not so much I'm thinking a ride, perhaps a NUCA to do DVB-T reception on 2 meters using the vertical 2-meter antenna. The reason for that is a lot of people have verticals for 2 meters, but they don't have horizontal antennas. So it may actually potentially create some more experimenting where people try 2-meter ports down with an amplifier. So that's the thought there, but that's a later plan. We can do that next year. So the controller. So on the design, the video switching, transitions, digital on-screen graphics, lower thirds, picture-in-picture, output streaming, and all these are supported by the Blackmagic Design ATEM Mini Pro. They're around about £260 now, including VAT. But it's a lot of product, and enables you to do lots and lots of cool things. It also has an API to control it with. The media player is based on Guy G0GUI's PyDeck software, and the PyDeck software supports API integration of the ATEM and BitFocus Companion, which is the software we use for the controller. And that's really, really useful, as will become apparent soon. The repeater controller functions are all performed by BitFocus Companion. It's open source software running on a Windows 11 Nook PC on site. It's actually a Celeron. Doesn't have to be particularly powerful. And we also, through this software, by emulating Stream Deck, we can perform remote control actions via the public web port or control panel, which I'll show you later. So rather than using DTMF and all that old tech, we do it through the web portal. Also running on the Windows PC is VLC, and VLC is just there for one function, and that is for the audio announcements. And guess what? That integrates with BitFocus Companion. So that's another nice. It has lots and lots of plugins, BitFocus, and we can use all these to talk to all sorts of things. So we talk about this modified ride. It's pretty simple to modify. It's a bit of code. So in a standard ride receiver, the lock indication when a signal is received causes a GPIO pin to go low, and which in the case of our repeaters, in the implementation we use the URL lib library in Linux, and to send a command to BitFocus Companion software, which in turn triggers a Blackmagic ATEM transition macro to select the appropriate input. So magic buttons, magic fingers. So at the same time, the ATEM also starts a session recording So it actually records the transmission, and then members can access that later. It's publicized to Microsoft OneDrive, synced every 2 or 3 hours to Microsoft OneDrive, so you can go back and look at your recordings, and we keep them. We've kept them all since 2022 when we started this on GB3JV. When lock is lost, of course, when the transmission ends, another webhook is sent to the companion to return the repeater to the media player and end the session recording. And so I'll show you all that. The possibility also exists to send webhooks to other network repeaters. So, for example, if you have a repeater is suddenly in use, then there's no reason why we shouldn't tell the other repeaters to take the stream from the repeater that's in use and show that input. So if you access one repeater, all 3 repeaters light up with your output. Now there's some new features in BitFocus Companion which allow us to do that sort of thing, but the coding's fairly, or the logic's fairly complex to work out. So that's got to be thought, what do we do if someone's already using the repeater, etc. So a lot of what ifs, and I've got to sit down and do a big flow diagram. But right now the priority is getting these things on the air. So that's a later session, but it's the beauty of software control. You can do all this stuff. You can sort of, if you put the base architecture in place, you can then come back and think, oh, we could do this or we could do that, and people come up with ideas and say, oh, how about this, and we've done it. So that's the idea. Now to the automatic logbook. Now this is a recent thing. Now Tom van der Bon initially helped with this, and a friend of mine who I've known for a very, very long time, Tim North, he's lapsed, I think, but G8 SXR. We've known each other since sort of teenagers and stuff, but he's really good on coding, and he looked at this and looked at the ride, and with a bit of help from Dave and Tim, we produced this automatic logbook function, and it basically populates the QRZ.com logbook with an entry that includes the mode, signal strength, station ID, and MER. We pull that all off the inbound signal, of course. We also send a Slack notification to the user group showing the user's call sign. So you get a notification on Slack saying, the 70 centimeter input is in use or something, and it's G8YTZ or whatever. So you get that as well. So that's been proven to design to drive usage of the repeater as well. And someone sees someone's on, they have a look at it and think, oh, I'll come up as well and have a chat with them as well. BitFocus also sends its own Slack link to the group, which that's basically to the stream URL. And that was actually Roger Meakin's idea, and he said, "Oh, what about a link?" So when you get the Slack notification, you get the link, you click on the link, and your VLC pops up with the repeater stream, even if you're out and about on your mobile. So it works well. Obviously, if you a received web stream doesn't contain any call sign information, so we only send the latter notification, not the call sign, just to save the stream inputs in use. And of course we can't log that either for obvious reasons, but there again, it's not RF, so we need to log it. Okay, so let's go through very quickly how we actually modify the ride to do this. Well, the first thing you need to do is on your QRZ profile, assuming you've got one, you need to create an entry as a managed, a managed logbook or a managed call sign for your repeater. So on the logbook settings page, so once you've done that, you then go to the logbook page, and on the logbook settings page, you'll see there's an API key. Now you do need to, you do need, of course, to have an API subscription for this, which is not very expensive. I just pay for it for 5 years at a time. Was it 10 years? I can't remember. It's not very much money. It's well worth it because I use it for lookup on Ham Radio Deluxe when I put log entries in. The other thing I haven't done yet, which I'm going to do, is potentially sync this with Logbook of the World. But the other bit on top of that, the other possibility exists to perhaps create spots as well for HAMTV usage on repeaters. So that's another thought. Again, it's probably more like 2027 actually, because I've got so many other things on my plate. Unless anyone fancied coding it. Anyway, so back on the repeater logbook page, you'll see at the bottom some code. Add this logbook as an iframe to your repeater's website, which we've done that. So we've got a recently heard page on last heard page on the repeater website, so you can see who last used the repeater. Now, if you create a free Slack account, an application of an inbound webhook, that's quite straightforward, and that information is all on Slack and YouTube. You don't need to tell you that. But the unique webhook, you can add that in as well, and the webhook will then again tell the user group that the person who's using the repeater as well. So that's useful to have as well. So that can all do. Basically, it's two files. There's one file that's made for you to put into your ride, and there's one other small modification which we'll talk about now. So on the ride receiver, there's a file I can send you called webhook.py, and you just pop that in the ride player folder, and then you've got 4 lines to modify just for your own API key, repeater call sign, and your own Slack webhook URL. In your ride player states playback.py file, you've just got to add the line at the top of the file, import URL library request. That's the URL webhook library. So it's simple as that. Now we're going to add another function which is going to basically change the way we detect lock. Rather than just simply detecting lock and having all the problem of false locks, we're going to use this technology to discover a valid call sign and then do the switch. The nice thing about that is you could actually exclude people if you wanted to. So that's another thing, or limit the access to a defined user group. So that there's possibilities if it ever needed something like that. So let's have some practical demonstrations in that case. Let's go into our source here, which I'm going to need to look at the program output in big scale here and get myself, where's my, right, what's happened here? Indeed, what's happened here? Oh dear. Don't you know it? Don't you know it? my Linux machine's crashed. Oh, fantastic. How can that be? It's been sat there all morning working perfectly okay. So let's just reboot that up. Well, you couldn't make it up, will you? If something's going to go wrong, it will go wrong. It's just been sat there, been using it, testing it, and it's literally fallen over for some reason. So there we go. So let's talk amongst ourselves while the machine boots up, and then we'll go back to where we were. It means I'm going to have to... where's that happened? It does happen very, very occasionally, but it's decided to happen today.
Don't worry too much, Justin. Maybe a good reminder to everyone at home, if you do want to ask any questions, and while this is rebooting, that might be a good time as well. But you've got any time now before about 12:25 to ask questions of Justin, and I'll read as many of them to him as I can. Looks like your machine is almost there now, Justin.
Yes, it's quite fast at booting up, thank goodness. I just need to get the right I don't want that one, and I don't want that one particularly. That's the one I want. Yeah, it doesn't take too long to boot up. Here we go. It's just unfortunately just changes the. There we are. Let's hope everything. So very quickly, this is the network. This is GB3JT's network that we showed you. So we got complete control over the network topology and what have you, all managed online. I mentioned the recording feature as well. So this is the link you get when you go to the website and log on to the website. You get the link and you can go back and watch all the recordings. And so we go back to 2022 on GB3JV. Now the logbook. Here we are. This is the logbook of GB3JV, and you can see what we're populating it with. So we got this goes back to May, just before the repeater shut down. I think Roger was the last person in there. Shows you the exact frequency, or shows you the difference between frequency of different transmissions, and it's quite interesting because if someone pops up, you can tell what equipment they're using by the frequency. Then shows you the mode there, their grid, of course, which comes from their logbook entry, and this is their lookup on QRZ. And then in the comments section, we put a few more things there: the bearing, distance, and the signal strength, all coming from the RIDE receiver in there. If we go to the website now and we look at the logbook page here, there we go. You see an abridged version of last seen, as opposed to last heard. The other websites all up and running. Now this page here, we've got a similar page. I'm not going to JV actually, repeater control portal, and what you have there when we go to that page, there's a second sign in for this you need, and what you have is the ability to do picture-in-picture. So if you've got somebody, you have 70 SEM in the picture-in-picture and stream being the main frame, or vice versa, or 23 SEM or 23 SEM and 70. So you've got a few options there. You can send a Slack notify to say there's a net in progress. And the idea with this is you can have a net controller actually, in the picture-in-picture and bring other people into that. So it's a bit of fun there as well. This is the link to the session recordings. Once you're logged in and you hit that, and you get that other page I just showed you as well. It's exactly the same for the sites for GB3JT and also GB300, and this is all operational and tested and working. Now I'm going to show you BitFocus Companion. This is the interesting bit. So on the left here, this is version 4, so things have changed slightly, but you have the integration with Blackmagic Design, the ATEM, the Hyperdeck, which is our Pi deck I mentioned. It's not actually a Hyperdeck, it's a Pi deck that looks like a Hyperdeck, but the software only costs you £45 plus a Pi, a lot cheaper than buying the Blackmagic box. Slack I mentioned as well, and VLC, and I say that really triggers the announcements. Now let's go into surfaces. And you'll see we've produced an emulator for the Stream Deck and customized that, and it's that emulator which is used to provide the remote portal through a reverse proxy to the website. So that's how that works. We use what's it called now? I can't remember now. Anyway, we use a reverse proxy running on a Pi for that, sitting at my house here. Now the next thing, when we look at buttons, I'll show you this. These are all the buttons that make the repeater work, and each of these buttons has a webhook, and this is what when you detect a lock on a receiver, this is what the Pi does. It presses one of these buttons. K is the end of transmission, 70 SEM stream, what have you, and if you look at what happens, if we look at the 70 SEM input, you'll see that the initial action is to make sure the keys are off. That's all, the graphics are off. Then we set the upstream key. We set the upstream key off, downstream key off. Then we run a macro, and that basically on the ATEM does all the clever graphics and switches to that input. Okay, there's a wait for a couple of seconds, and then VLC does a voiceover, and the voiceover welcomes you to the repeater, and there's a wait there because there's a wait there, and Slack also sends the BJT web stream at the address, so that drives people to just be able to click on that link, and then we have another wait, and the ATM recording starts. We allow 3 seconds when we start recording, and that's basically what that button does. And essentially the ride presses that button, and they're the other buttons you can see here. So that's essentially how that works. The other important thing is the triggers. This is basically the RoboJock that controls the media players. So 1 a.m. we basically, if we look at that is basically voiceovers 1 p.m. or 1 MP3, and that is actually, and it runs a chime as well, and that's basically VLC that's doing that. And then if we go into on the top of the hour, we also put up a logo with the Kent horse in this instance on this repeater, and then during the rest of the day there's test cards and music, etc. And that's how it tells the hyperdeck to go off and play it, etc., etc. So that's basically the schedule that runs the media player, and this is all free open source software. Okay. And by the way, that's the page that gets presented onto the web portal via the reverse proxy. Now, what I'll do now is I'll show you. Let's get rid of this one. I don't need this one. Let's get rid of that one. That's okay. This is where the reboot didn't help me much. But if we go into Documents, CAT25, I was going to tell you about these files, and these are specially sanitized, so all my secrets aren't in there. But if you look at your playback.py file, basically it's a standard playback.py file off the ride, and this is the line you need to put in: import URL library request. Okay, so that's that bit. Very quickly, when in this area it is runs the GPIO pin to detect lock and signal the transmission. So what we have here is we do a post request. So this is basically telling to press button 1 on the left. Okay, and at the end of transmission we do a similar thing here, but we press button 3, which you might remember from those buttons is the K button, which puts everything back. So that's and then we do a different display text as well. We just put the website and the input, etc. in there as well. So that's really how the instead of using GPIO, we just use a webhook in there. So that's just cover that file quickly. If I open the webhook.py file, this is the new file, and so there's a few few things to change on this one, which I'll just bring this up on my other screen quickly, and I'll tell you what they are. Here we are. So on line 29, we have our post URL put into there. This is the one provided by Slack for Slack notifications. On line 89, you've got something to change here, which is basically you might want to change the message so it says GB3 whatever you are, 77 input is active, or whatever input it is, and followed by the call sign that's been pulled up from the incoming stream. So you obviously want to change that call sign in there. Then line 127 is the one where you this is the logbook entry, and obviously you want to log it to the correct logbook, and the one that's got your API key from qrz.com, and that's what the API key looks like. from qrz.com. You put that in line 134, and that basically is it. You can do this to any ride basically. The only other requirement you have, of course, is an internet connection to the site. But if you haven't got an internet connection, this doesn't use a lot of bandwidth. You might as well just get a cheap SIM card and a router thing. These are quite good. These are available. This is actually VPN server and everything. This is a go back to my main camera feed here, which is number 3. It's going to show you this in a bit more detail. This is a USR IoT box from AliExpress, and this is a 4G modem. It's got internet. It can actually act as a backup. You can loop through it as well. It's got all the bits on the side. Very nice little box. This actually provided the streaming for GB3JV until we put the 5.8 gig link in back to my house. So they're really good little things. I'll show you this QIT thing quickly. This is a 2-meter receiver. It's these things. It's actually allegedly waterproof, but there's the multi-pin connector. I think it's pin 4. You've got the audio on it, the audio output, and of course it just run off a little power supply. You're not transmitting on it. And this is when you set it up, you initially set it up with this. In our case, CTCSS. Set it up with this, and then you can unplug that, and the thing remembers itself. I left GB3 unplugged for GB3JV unplugged for 3 months, and turned on. It was all remembered all its settings and everything. So that was another useful thing to do. I'll put this over here. It might fall off and damage my porcelain floor. We wouldn't want that. Right. What I'm going to do now, very quickly, before I finish, is I'm going to show you. Let's go this right. That's it. I need to. What I'm going to do is going to switch over to GB3JV, okay, which is that one. So let's switch over to GB3JV. You should still be able to hear me. Well, you won't be able to hear me over the test card and music, of course, but nevertheless, let's go back to JV. And what I'm going to do, I'm going to use my iPhone to stream into the repeater, so you can actually see what happens when we stream in.
Hello. The GB3JV web stream input.
So that's just
Your session is being recorded.
To the web stream. Okay, so that's just the transition. Hopefully you've heard all that. And I'm just going to pop outside to the hall and show you a repeater, a real live repeater. And I'm just going to pop out. So this is GB300, just sitting in my hallway at the minute under test, much to my wife's delight. And you can see all the lights flashing and everything, and it working away doing its repeater functions. This section up here is all for the RF, which is not in there yet. It will be soon. Here's my beautiful Pico tuner with the cases, quick plug for those, and of course the telephone on top of the repeater. Back in the study, which I've got loads and loads of stuff in here. Here's the other one. This is GB3JT. Again, it's doing its stuff, and all the complicated stuff is done. So I'm going to now just hand back quickly. You'll get the music again because we haven't taken time on this test card music. I'm going to stop this transmission, and I'm going to stop this transmission. And okay. Where are we? Oh dear, it seemed to have gone off the screen. Never mind. Oh, end. There we go. There we go. Oh dear, it seemed to have gone off the screen. Never mind. Oh, end. There we go. There we go.
Goodbye. 73s and 88s. Goodbye. 73s and 88s. Da-dee-da.
And there we go, a quick demonstration of what the repeater looks like. I say the music is it just happens to be test card of music at that time. So Yeah. Anyway, I think we're just about done, and I'm thinking of putting a little BATC article for CQTV together to explain how to do all this. But there's a quick overview of the new logbook functionality which we developed earlier in the year. Must have been up to March, so I think we've been testing it really well. And then we lost the site, which was a bit of a shame, but we're implementing all repeaters. Okay, that's that, I think.
Okay, well, thank you very much, Justin. A real good luck. You're very brave doing a live demo like that, Blue Peter style, but although they record that now, you know. Anyway.
Can't believe it crashed, but anyway.
Well, no, that's just
Linux PC.
That's just what happens. We've only got a couple of minutes really before we start our informal lunch session. Although if you and others are joining that, we hope you will via Zoom. Starts in about 5 minutes' time. Then you'll be able to ask questions of Justin and talk to all sorts of other people as well. But we've got one comment for you here. Andrew M1DNS says, Justin, not so much a question, more a showing of interest. He's not a Slack user, but a long-time user of Telegram. Could be something we look at in the new features we're adding to GB3NQ.
There's no reason why you shouldn't use Telegram in the same way, or many other products. The reason I use Slack is because a lot of people seem to have it already, and I was familiar with its use. And I tend to think if we're going to do this across the board, then maybe if everyone stuck to Slack, we could all just subscribe to their feeds. But you know, it's obviously your decision how you approach it.
Okay, thank you. M8MDJ says, interesting to see Slack is still in use because they use Discord these days.
Yeah, well, Slack, I would say I was doing I was also, the other thing about Slack is they're still in use. It's the darling of Californian tech companies. And I was working for a large Californian tech company that makes mobile phones and lots of other services. And they introduced Slack within the business. And I mean, to be honest, it's internet relay chat. It's nothing more than that with a fancy front end. But the documentation is good on the website. But there's no reason you can use any method of notification that supports a webhook. It's kind of your decision. But I tend to think if everyone did the same thing, we could do it all with one app. But no, your shout.
Yeah, I must say it's brought back memories for me to see a test card again, really, because we don't often see test cards nowadays, certainly not on real TV, as it were, because they're just transmitting and broadcasting all the time, aren't they? Lots of other little comments for you. They're all compliments, really. I won't read one of them out, but Nigel Reeve says, what a good presentation. Thank you, Justin. Tim G4LOH says also, thank you very much. And
thanks, Tim.
Andy MUX says, can't wait for the OO install, Justin.
I bet.
And also...
Yes, I can't either.
And Jen G4HIZ, looking forward to the new Kent repeaters. Jen will be joining us later on as well for one of the talks. And Gareth G4XAT, our chairman, of course, says 10 out of 10 for a live demo. I agree with that. It's very brave of you to do that, Justin. Thank you.
I can't believe that thing crashed.
It's
all
right.
I really can't.
Especially if I've got several friends who just believe Linux should run the world. So that's a shame it happened to Linux. Because they'd be mortified. I expect you are, really. But anyway, thank you so much. There is one very quick question we can get in. Rob PA1EMT, are there any problems with DATV stream delay? But I'm not sure if I'm not sure the context of that. If he's asking if there's a problem, what we're doing now, or can you take that?
Yeah, all I can suggest is, the answer is yes, you can have problems. I know our friends in Australia have issues, but we use the Blackmagic output on these repeaters, and it's worked very well over the last few years. All I can suggest is you go onto the streamer on the BATC website. You can see all three repeaters there. The only one which is slightly not right is the OO is actually using g8ytz.com at the minute. Sorry, it's using the G8YTZ stream on the BATC website. It's using my personal one, but JV and JT have both got their own pages and streams. But take a look at the websites as well. If you fancy signing up, you can also join the Slack group, or just keep up to date with what's going on the repeaters. The remote portal, I am restricting that access at the minute to just a few people, because it's kind of, I had it in beta for a while, but it's going to come into its own when we start doing nets and but yeah, no, just to have a look and see. I would, and if you sign up, you can, welcome to stream in as well. You get the stream key when you sign up.
Lovely. Okay, well, thank you very much, Justin, for this. Thank you for your questions and comments as well at home, and compliments as well. Now, coming up now, something different, which we're calling the ATV Packed Lunch, which later on will include an exclusive look back at Aris UK's live ISS link-up last weekend. But before that, you can either watch on BATC Stream or YouTube, as you've been doing now, or better still, join other members in person via Zoom using the link we sent on the newsletter, or download Zoom and sign in using the details that you're going to see very shortly. And this session, open session, will be open until just after 1 p.m. So you've got just under 30 minutes or so to interact with a sort of an informal lunch, and then we'll be watching that video. We look forward to meeting you soon.
Libraries and everything. So what I was planning to do was a single build that you could make either as a ride or a Portsdown, if you know what I mean.
That makes sense. That makes sense. Yeah, the on-screen display flickers, and the audio doesn't work for reasons yet to be determined.
I'm having all sorts of similar issues.
Yes.
Good morning, Mike. Or afternoon, Mike. Who else we got?
Hello there. I don't know if you can hear me.
Yeah, we can.
Great. Well, the thing was that seeing as you invited me, here I am.
Yeah, exactly. Have you got any things to discuss about what you've seen this morning?
No, I'm trying to absorb the information. Some of it's going over my head, I have to say, but my interest really are the Portsdown, and I saw Tim there in the ride. I've got a ride behind me. It's not connected up with a Portsdown 3 to my right. How easy is it to convert from 3 to 4? I do have a Pi 4 here.
If so, your Portsdown currently, what screen has it got on it? On the 7-inch?
Yeah, 7-inch.
So you just need to change the Raspberry Pi for a 3 to 4, clearly, and change the SD card.
Oh, okay. That's simple enough. I thought it was simple, yeah.
Some of the GPIO connections, not many have changed, some are no longer used. But you need to have a little audit of the GPIO connections. But essentially,
I've got an idea about that.
Essentially, you just change the Raspberry Pi and the SD card.
Great, thanks very much. So,
yeah.
Right.
Hi, Justin.
Hi there. I'm back again.
I can't believe Linux crashed on you.
I know, it's just a solid light, and it sits there for days, that machine. You know?
The live demo detector worked again.
Yes. Still, it boots quickly. That's one thing about Linux.
Yes.
I've got everything here. The presentation was on a Mac, and the Zoom's on a Windows machine, and the browsing and everything else machine I did the presentation was on the Linux machine. So there's 3 machines to go wrong potentially. But you can always rely on the ATEM though.
Yeah. Did you read my ATEM repair article?
Yes, I did. That was quite interesting. It kind of worried me at the same time.
I think the lesson is keep them cool.
Yes, yeah. There's shelves. There's lots of air blowing through that. I mean, I haven't got the fan switched on now because there's no RF. But you probably noticed that all the sensitive stuff's at the bottom and all the hot stuff's at the top. Yeah. For that reason. But yeah, that's quite a job. I do actually know a guy who's very good with these sort of surface mount things, and he changed the eMMC chip in my car when it packed up. So he runs an MOT garage, but he used to do surface mount, so he's got all the kit. So,
right, yeah.
But the clever thing there was, pulling the on the car. There are 2 petitions which contain the certificates for the VPN, the Tesla VPN, and it's extracting that important information. So you lose those, you're done for. Tesla won't give you another one.
So, right.
So, that's the clever bit.
A message from Mike. You can probably drop the QO100 for the next half hour. I think it's probably more appropriate not to have this on QO100, but it's a really good feed for this morning. Thank you.
Yeah. Brilliant. I was looking at Gareth's camera and I was thinking to myself, oh, he's got a low emission tube.
Yeah, it's just I'm not sure what's up with that camera, Gareth.
No, I've tried resetting it and looking at the settings in OBS, which I'm sure it was fine on Thursday night. Otherwise, people have said, "What on earth's happened to you?"
No, it was fine on Thursday night.
Yeah, I mean, I can't see anything that's wrong. I don't think Windows has done an update since then, but it's horrible, isn't it? It's like it's Channel 5 in the early days picture quality.
Yes, with the ghost in the South London ghost.
Yeah, I haven't got a ghost. It's just the pixelation and limited color palette, like 256 colors or less than that, even 32 colors.
No, it's
whatever.
a low emission tube on your camera.
I've got the Razer software that comes with the camera, and just run an update on that, and the camera seems to be fine. It's like I've got no idea. HDR.
I mean, I'm using
What's that
here
short for? I'm just reading what Mike's posted on the post.
high dynamic range.
All right.
Yeah.
It's. I mean, I haven't set it. It must have set itself. So if
Yeah,
I find
that will affect it. Yeah, that will mess it up.
if I move that up there, and then find the camera software, unless it's doable in what's it called? Razer, isn't it? Razer. There we go. Open.
We'll let you play with that then, Gareth.
Yeah.
Hello, Benno. Welcome to the chat. Silent, Benno. No audio, Benno. Oh, he's gone. I scared him.
Cameras I use in here are generally the Sony AS30s, which are obsolete now, but I've got a couple of, they're like action cams, but I have got a really nice Vlogger camera, which I also use, but I haven't set up today. I just left these ones here in the shack. And,
must admit, I'm on the old C920
Oh yeah, yeah, they're nice.
Really well.
I've got a pair of those too. Yeah.
Works now, Dave.
Yeah. Oh, good. Okay. We haven't seen you for a while. You've been out and about for the summer, haven't you?
Yeah, but working on different projects. Working on Whisper.
Oh, right. Yeah.
So that's not real DADV.
No.
Nope.
But
loved your presentation.
Half of my projects aren't DATV either. Yeah.
Yeah. Well, you're not talking about those projects as well.
I wonder how long it would take to get a 5-minute program over Whisper if high quality, high definition TV. What's the data rate?
I have no clue.
Is it seconds per bit or something?
Yes.
But Justin, I need to come into contact with you. You know, I use 3 rides for our local repeater. So I love the logbook idea there.
Oh, yeah, I can help you with that. My email's on QRZ.
Yeah,
so,
but first I need to talk to Tim about this ride project, because I use Node-RED, and I want to make messages between ride and Node-RED. And I know it's matter of the right message and the right coding. But first of all, I need to talk to Tim about that. But I'm trying to reach him for at least half a year now.
Yeah. Well, there's no reason why you shouldn't use our bit of code to send a Node-RED. It's just that the endpoint you're changing, that's all. The endpoint I showed was the one for the logbook format, which is a standard format for all these logbook systems for QRZ. I use QRZ really because I had it. So it's but logbook of the world, it could go to that as well. But I thought I'd do that via QRZ. So just send to QRZ and let QRZ do the logbook of the world update. I just haven't had time to actually sit down and think that one through. But it's not very difficult.
Benno, Tim looked puzzled when you said you hadn't been able to get in touch with him.
Well, yeah, I haven't seen any emails from you, so I wonder if they're getting lost in the void.
Probably not the right address, Tim. But we need to talk when you have some time about this idea I have.
Yeah, it should be fairly easy to kind of, as Justin has done, you can hack things into it in various obvious places. I've got a few too many other things that need to go into RIDE first before I can add it add new things as official features, because I've got the Pi 5 and the HAMTV to go in first.
Well, I think you don't need to modify anything to the RIDE, as it has the feature already for controlling via the network, as Tom does with his remote control. I mean, all the commands working basically. So now I need to let my Node-RED instance talk the same commands to your RIDE instance. So in fact, all the hardware is there. It's just I need to know the exact command, as Tom has probably backtracked.
So you're going to emulate Tom's software effectively.
Yeah, basically on, but then from the Node-RED instance. I mean, Node-RED is controlling my complete repeater, but I use all the hardware commands, all the hard lines to control the RIDE, which is basically ridiculous. And you can do that much better with network control, I believe.
Yeah, you can. There is some documentation that tells you what all the commands are, and you can do button pushing, but you can do a few other things other than just button pushing as well. You can send it direct, like tuned to this settings, and controls like that as well, rather than just button pushing.
That's also something I need for the near future, because I want to experiment something on 6 meters with inputs on our local repeater on a 6 meter channel. So therefore, we are using the one RIDE for multiple bands, and this is more or less button pushing for preset selection, but the better doing that via tuning on a network command.
There
So,
are.
Let me go into that now, because that's probably way out of the league where we are talking about during this lunch. I need to
Just
talk
to say
to
that
you
on the GitHub there was some documentation and at least one example Python script of that should have everything you need.
Good. Has anybody else got any questions, perhaps for Charles, from Donald, Don, or Keith, or anybody?
Charles, I thought your presentation was absolutely fantastic, by the way. It was a real... I'm quite interested in AI myself, and I really did think it was fantastic. And the ability also potentially to improve the susceptibility to signal loss, you know, perhaps pull out weaker signals still using some of these techniques would be interesting as well.
Yeah, and there's quite a few people actually playing about with this stuff. There was some guy in Switzerland that was using it for propagation. I get all this stuff on my Twitter feed, or X. So it's but it's difficult to keep up with it. There's just so much going on.
Yeah, I've been playing a lot with the personal assistants on Grok, and I've got this sort of idea in the back of my head to introduce one on the repeater. So there's no one on, you'll have Annie to talk to.
Yeah, why not? I mean, I've got my own personal assistant that's based on an open source model, but I've been augmenting it with things like, as I said in the talk, it can ask my solar system what's going on and stuff like that. Like for the other day, I said, "Is it dark outside?" And it said, "Yes, it's dark outside." I said, "How do you know it's dark outside?" "Well, I've looked at the power coming from your solar panels." And I've also got some cameras hooked up to it, because although I'm using a text model, using the MCP tool, I can call a vision model so that I can pass pictures to it, and then it brings back text, which the GPT ISS, and I said, "Oh, you know, is it using your cameras? Is it dark outside?" And he said, "Yes, it is dark outside. Your camera is operating in infrared mode."
Oh, brilliant. Yeah, it's
which I mean, it's unexpected, because I think it, you know, you look at the picture and say, "Oh, there's, you know, it's low light levels," but
well, the clever. I mean, if you look at some of the videos on Tesla's full self-driving in the States, there's a great one this morning on Stephen Mark Ryan, that actually shows the car making a left turn, and there's some geese in the road. Actually, it's a road. It's like in a car park. There's some geese, and after a while, it realizes they're not moving; they're just sitting there, and decides to turn around and go around them. You know, and that is all basically AI, you know, the neural network doing that, and actually thinking, what shall I do in this situation? You know, rather than just sitting there, it actually went round them. And,
yeah, but they've rewritten that code about 3 times so far. Every time a new technology comes along, they rewrite all their code. So
it's incredible where it is now on the 14.1.3. Absolutely incredible.
Well, I don't have a Tesla, and I must admit, I had the opportunity to use a Waymo when I was in Santa Monica, but I chickened out.
No, I mean, my wife's Model 3, I've got a Model S, it's too old for this tech, but my wife's Model 3's got the FSD package. It's just we haven't got it in this country yet, which is really annoying because they got it in Australia.
Yeah, I noticed that Waymo are starting operations in London next year. That'll be amusing to watch.
I don't think it's scalable, because you've got to train the thing and update HD maps and things. You know, it's just not scalable, and the cost of those cars. How are they going to make a profit?
Yeah, I mean, it's interesting that in Santa Monica, the Waymos will not go to the airport. They won't go to LAX. They stop short of LAX. I guess.
Yeah, that's changed. You know, that LAX have actually put a whole bay for self-driving autonomous taxis now. Yeah, only recently, the last couple of weeks.
Yeah, is that near where the pickup is for Ubers and things like that?
I think it probably is. It's a while since I've been to LAX, but as you know, you have to pick the right area for the flight that's arriving, don't you? You know.
Yeah.
That place. I remember picking my daughter and wife up there quite a few years ago when I was working out there. I really do think Tesla's model is the one that's going to win through on cost alone. The fact that it self-learns, you don't have to train everything and keep retraining, and road layouts change, you've got to back retrain it. You don't have to do that with this. It's intelligent. And,
Can I drag the conversation back to ATV? Has anybody got ATV questions?
AI touches many areas, doesn't it?
Yeah, absolutely. Yeah, we've got lots of people without cameras on. I wonder if any of them have questions.
Maybe they've got cameras like Gareth.
Maybe they have. Oh, there he is.
Oh, he's back in the right colour now.
Yeah.
Oh, well done.
Oh, yeah. What have you done, Gareth? That looks a lot better.
A full reset and wade through the menus that I don't understand, but it is at least human again.
Yeah. Almost a bit saturating on.
Yeah, I've found that menu. I'll have a play with it, but at least it's working.
A lot better. Yeah.
Yeah. Okay. Thanks for tying things up this afternoon. I'll have to go once this chat's over, but I'm looking forward to catching up with that talk.
Mm-hmm.
I've got to head off soon. I'm up the road to the church hall to do the repair cafe, which I do once a month or so. So probably broken vacuum cleaners and the like. It's fun.
Terrible the amount of stuff that gets chucked away simply because it's blocked or they haven't cleaned the filter or whatever.
Yeah.
It's amazing. The lack of common sense is worrying. I don't think AI will help it either, because if AI asks people how to fix their vacuum and they don't know, it's not going to come up, is it? Work that one out.
Very true. Yeah.
I've got an air purifier that needs fixing, but I haven't been able to take it to pieces.
Yes, that's the other trauma. The anti-tamper fittings, which need workarounds or a full tool set, or just not designed to be taken apart. I had a Miele the other day, vacuum, and that came apart like it was planned. So it's a proper good vacuum, I have to say, well worth fixing.
German engineering.
Yeah,
I've got a Miele, a fantastic machines. It's I can show it on ATV if we bring it back on something. But no, I like the Miele.
Yes, Mike, your microphone does work.
I wasn't sure because it's not lighting me up.
No, I'm not sure you're talking loud enough.
I'm talking very loud, same as always. I think it's got the wrong gain setting.
It's just done it. Yeah.
Right.
Thank you very much for the contact on QO100. That's going well.
Mm-hmm.
You can always tell how well it's going by how quiet the rest of the transponder goes.
Yes. I take that as a positive for the Thursday net.
Yeah.
I'm going to sign off simply because I've got to get ready to go up to the repair cafe and do my bits.
Okay, Justin, thanks very much for your lecture. That's good.
Oh, it's a pleasure. Enjoyed it as well.
Yeah, thanks.
Okay, I'll say goodbye anyway. Bye, everyone.
Cheers.
Yes, I'm rapidly moving towards being able to get on the Thursday net. I've got my new camera system that I think is doing a reasonable job. first real test of it, and I got to finish sorting out the dish, and I got an amplifier on the way from Poland, so hopefully it won't be
Okay.
too much longer, and I'll have
Brilliant.
on the net.
Yeah, that's good. I hope the dish does good service.
Yes, I'm just kind of trying to touch up all the very slightly rusty bits around the edge, because if I put it outside in Wales, it's just going to turn into a big pile of rust if I don't make it completely sealed up before it goes outside.
Yes. Yeah, it turns out paints are, I mean, in the old days, it just stick some hammerite on it, but hammerite stopped being good many years ago, apparently. Still, rightio, I'll have to go soon as well. So I'll sign out and have a play with the camera when Zoom's not using it and get it back on track. Thanks for the pointers.
Cheers, Gareth.
Bye, Gareth.
Cheerio.
Right, the headset might work.
It does.
Apparently, though, according to you, Dave.
Yes, Mike. Sorry, Tim.
We're starting again at 1 o'clock. Is that right?
Well, they're going to run the ISS video around 1ish. Once David and Tammy start running that, I think it'll be appropriate to put the Q100 back on.
Okay. I'm not sure I can do that in Zoom at the same time. I might be able to.
No, the Zoom will finish then.
Ah, right.
Yeah. So basically, when the Zoom finishes.
Well, I've done a new 3D case for the Pi 5.
So which way up is your screen?
The correct way up. So you set it the wrong way up in your script. I have to reset it back.
Right. So I will shortly change my screen around and then I'll sort the script out.
Yeah, VLC is the right way up on this one.
Good.
I can show you if you like, but
VLC fooled me the other day. I went to the beacon and it was the right way up, and then I went to somebody who was running H.265 and it was the wrong way up. Yeah. Oh, it's got 25 way on it as well. That's good.
Yeah, it's got the old. I think you said I can power it from the standard little power supply, little switch mode power supply, the Pi 5. I was worried about the current it takes.
No, it itself doesn't take much. It's just provision of current for the peripherals.
Okay.
Yeah.
So we can put those components in which case it's exactly the same board, so no change.
Yeah.
The only thing is, because there's no audio, well, there's no audio, so I need to find a solution to that.
Well, one of these.
One of those, yeah, but then that sticks out of the USB socket and it looks untidy.
It does. You're right. Yeah.
Are there buses on the? I think there's some kind of serial bus on the DSI CSI ports that might be able to be abused to attach a sound chip to.
Really?
Oh, there are, yes. That's how the hi-fi berry works, I think.
Yeah, there's some kind of serial connector in there, because that's how they do things like control. It's the back channel control for the and I think that's how the touch screen.
The touch, yeah.
Yeah. And the things like the focus on the autofocus camera and things like that. So I think there must be an I2C or something bus in the connectors.
So we'd be looking for an audio driver that presents that and something. Yeah.
It's that, or you got to put it on the GPIO.
Oh, I could plug in my headset.
What, a USB headset? Yeah.
Mm.
Yeah.
Can't you use Bluetooth?
You've been reading the chat, haven't you?
No.
You can, yeah, of course you can use Bluetooth. It's just another variable, and the thing about Portsdown is trying to keep it simple.
But now it's all modular and well written. Shouldn't be so hard.
If somebody was exceedingly keen, you've obviously got the PCI Express connector on the Pi 5, so you could wire a PCI Express sound card into that with a pile of adapters.
That is overkill by any. Yeah.
Or you could just monitor with HDMI instead of DSI, I guess.
So have you been watching, was it Jeff Geerling and him sticking video cards into Pis?
That's one way to solve the encoding problem.
Yes.
What about using a camera that does it for you? Is that possible, Dave?
Well, I mean, something like the C920 that I'm using.
Yeah.
But of course, the lowest bit rate, it'll do about 2 megasymbols.
Yeah.
Any lower than that, it doesn't. But yeah, yes. That's a cheating way. But of course, everybody wants QO100. So
yes, but no.
Yes, but no, but yeah.
Yeah, because even the really cheap NVIDIA cards have encode on it. So my very old GT720's got H.264 encoding on it.
I thought it actually didn't have the hardware in the Pi 5.
No, it's still there. It's just the interface is a 32-bit interface. And because they're trying to push everybody to 64-bit, they decided, everybody can encode in software now, which is fine if you're encoding at 4 megabits a second, but not at 333.
Yeah.
Or lower. I mean, off-board encoding is what I use on QO100 for using a Jetson, a very old Jetson now. But is there anything cheaper available in the Jetson range, the new Jetson range? Charles, do you know? Or is it all expensive? You've just muted yourself to unmute.
They've become very expensive.
Why don't we design a hat with an encoder on it?
You've got to find the encoder.
That'd be the solution, wouldn't it?
Yeah, H.265 encoder.
It shouldn't be too particularly because you can put it on the PCI Express bus on the 5. But you've got to find the chip, whatever your encoder chip is, and find a source of them.
Absolutely.
Or an FPGA and a license.
Yeah, I see David's put up a note saying informal lunch session will end at 13:05, so we've got a couple of minutes more.
Yeah, well, apart from the image, I can keep going.
I'm trying to burn electricity at the moment.
Have you got storage there, Charles?
Yeah, that's the problem. At the moment, till 3 o'clock, Octopus are giving away free electricity. You can have as much as you like.
Yeah,
I've got everything turned on in the house.
I'm exporting 3.3 kilowatts because I'm not using it. Incidentally, this entire thing has been solar powered.
That's good.
From my
credentials.
From my uplink to the transponder.
That's good. Right, I'm going to shoot off and get some lunch. I'll be back at 1:30, but I shall watch on my iPhone the ISS thing.
Yeah. Well, I'm off for a cup of coffee, I think.
Yeah.
Yeah, I'll put the transmitter back on.
Thank you very much, Mike.
Thanks for that, and it's a good point to let you know, it's David here, that our ATV packed lunch, we're closing our open interactive Zoom session any moment now. Thanks to everyone who participated, and please now go back to BATC Streamer or YouTube to watch the rest of CAT25.
Thanks, David.
Right.
Cheerio, guys.
Bye.
Cheerio.
There we are. Hope you've enjoyed that interactive packed lunch session. If you did, then please do let us know. We will do it again in a future event. Last Saturday, 3 scout groups based in Royal Leamington Spa in Warwickshire made an ISS contact thanks to the work of ARIS UK. The groups were 1st Radford Simele, 1st Sydenham and 1st 6th Leamington, plus the Explorer unit, which is called Trident. Participants ranged in ages from 6 to 18, and their usual scouting events included camping, hiking, kayaking, climbing and working on community projects. But over the last 10 months, their activities have focused on space and the ISS. They've also been building printed circuit board projects and using stars or the sun to navigate and gauge direction. This was a direct contact via amateur radio, allowing students to ask their questions of astronaut Johnny KJ5HKP. The amateur radio ground station for this contact was south of the town of Royal Leamington Spa in the UK, and amateurs used call sign GB4RSS from the ground station to establish and maintain the ISS connection. The space and ground teams also attempted to use the recently installed HAMTV device, which would be another step in recommissioning the HAMTV system that was returned to Earth and repaired after a failure in orbit in 2018. Let's have a look.
So I'm going to bring you now to another person. This person is known as Robert. This person I know is a bee leader, as many people are, but they are superhumans who do more than one thing, which is amazing given the time they spend on bee leading and actually having time to do anything else. Robert, if you read his profile, is actually another professor of space physics, which he does bring with enthusiasm to his work in 1st 6 Leamington. He has a variety of things on his website, what he does, but he particularly, I guess, is looking at a number of areas in space, again, quite related to space weather, but he works with the University of Southampton. He works on things like magnetic reconnection, solar winds, and global magnetosphere dynamics. So we're hopefully going to try and bring that into something that I can understand, if nobody else can understand, but it's some really good stuff. I think the key thing here is, yet again, like Susie, another volunteer gives time to others, helps other people learn and grow and develop in the world, but also is a brilliant person who can tell us lots of stuff about what they do in life. So I'm going to hand over to Robert and become his assistant at some point and see where it takes us to. Robert, the floor is yours.
Okay, thank you very much. When I wrote those words, I had no idea they'd be read out to a bunch of scouts, but it's been great to hear all the stuff that you guys have been doing as well about different things to do with space. So, yeah, as Mark says, I do a very similar job to Susie. I don't climb as many uncharted mountains, and I've never trained to be an astronaut. But I have a slightly different favourite planet, because my favourite planet is actually Earth. And what I'm going to show you here is something that, although I'm not going to talk about the space station, this is something you can see from the space station. On the screens, you can see a picture that's been taken by a European astronaut called Samantha Cristoforetti. And when she went to the space station, she took this picture from a window at the bottom of it. So you can see at the top, the white thing there is the underside of the space station. The right-hand side, you've got a bit of a solar panel. And the long thing that bends here is a robotic arm. And the curved bit you see underneath is the top of the Earth's atmosphere. So you can see the Earth is indeed round. And there's a kind of a green glow there. Does anyone know what that is at all? Yeah. The Northern Lights, yes, also called the Aurora as well. Has anyone seen the Northern Lights before? Where did you see them? Shout out some places you saw them. From my window. Lapland, yeah, hearing some places north, and I'm also hearing Warwick and other places. So we'll talk. It is really unusual to see the Northern Lights around here, but it does happen, and it happened last May. This is actually a movie that I'll play, and as you see, the International Space Station is orbiting around the Earth, and it happens now to be going near the pole, the North Pole, so near the top of the planet. And that's why we see, it's close enough to see the Northern Lights. That happens near the North Pole. You can see it's very changeable. There's lots of ripples and changes in brightness. It's kind of green low down, but it's actually a bit red higher up. Very bright bits there as well. Can you see bits flashing on and off here? The bright thing there is just the moon coming into view and up and above, and lots of flickering and all sorts. So the Northern Lights, you might see with your eyes. You probably, if you've seen it, it might have been quite changeable. It might have been quite static. But indeed, it's really, really very changeable, and you can see it on a really large scale as well. So that's what it looked like from the space station. This is what it looks like from the ground. For anyone who hasn't seen it, I took this picture. I was in Iceland and lucky enough to be at the right time to see the Northern Lights. And this is from the bay in Iceland, in Reykjavik. And that's what it looks like from a camera, taking a picture that lasts a few seconds. So what you see in that time is a build-up of all of that. You don't see that all at once. And then the next picture is literally a few seconds later and a few seconds after that. So you can see it really changing quite a lot. But those greens are kind of what I saw at that time. Okay, so some people mentioned they'd seen it from their window here and from Warwick and so on. So I'm going to talk a little bit about why that is. Does anyone know why we get the Northern Lights at all? Yeah? Nearly. It's not because of the sun's light, but it is because of the sun. So I'm going to show you now again, it'll be a movie of the sun. And I've got to emphasize, you should never, ever look directly at the sun. You will damage your eyes very badly. But we have very special cameras, sometimes on satellites, sometimes on the ground, that will take pictures of the sun. And by taking it in a very, very specific color here, we've been able to take a picture. This is actually from a satellite, a NASA satellite called Solar Dynamics Observatory. Take a picture of the sun and all of its structure. So you see it's actually, for a start, a lot more interesting than you think of when you just draw a yellow circle. To give you a bit of scale, this little dot in the top that you might be able to see here is the size that the Earth would be if it's there. So would anyone like to guess how many planet Earths you could fit inside the sun? Yeah. Bigger than 250, yeah. 3,000? Bigger than 3,000, yeah. I'll tell you what, I'll cut to the chase. It's over 1 million, okay? So the sun is absolutely huge. But look at the size of the Earth compared with all of this stuff here. And that interesting stuff on the front there is why we got the Northern Lights down here in Warwick and Leamington, and indeed further south. I work in Southampton, it was seen down there, and other places. So as I play this is again a bit sped up, but you can see, for a start on the side, all those wispy bits, that is the start of what's called the solar wind. The sun's a very hot ball of gas, so hot it becomes what's called a plasma. That flows through the solar system, it's called the solar wind. And you see really flashy bits. The flashes are flares from the sun that gives off a lot of light in these flashes, and linked with that as well, again, there's a lot of this very hot gas being given off. Okay, and so that particular set of that movie was from May last year, and a short while later, we saw the Northern Lights down here, and the reason is because here's another little sketch to show how the sun links to the Earth. This isn't to scale. If the sun was really that size, the Earth would be way off to the side. But the sun is always giving off all of this very hot gas, and then that hits the region of space around the Earth. And does anyone know what do you think the blue thing looks like? Yeah? It is indeed. I'm very impressed. It is the magnetic field of the Earth. And that kind of protects us a bit from the solar wind, but it also means that it kind of funnels these particles to the regions around the pole, the stuff to do with the solar wind. And that's why we see the Northern Lights. These are pictures not from Lapland and so on, from down the road somewhere here in Warwickshire. And then on the bottom left, that's from Norfolk, so kind of same latitude as us, just a bit further east. And the ones on the right are from down the south coast of England. And so that's the aurora that we saw, the Northern Lights, also called the aurora, that we saw last year. And so to understand the reason why we could see it here, we need to think about what it looks like from when really high up. So you've seen what it looks like from the ground. You've seen what it looks like from the space station that is literally just above it. If you have a satellite that's a very, very long way above, you can get pictures like the one on the left. That's real movie from a satellite called Image. It was a NASA satellite a few years ago. On the right, it's a simulation. It shows you get the Northern Lights, but also lights around the South Pole, the Southern Lights. In fact, these are the Southern Lights here. The white mass you might see in the middle is Antarctica. And what shape does the aurora, the Southern Lights, look like to you? Yep. It is a circle. So that's why, so for a start, if you want to see the Northern Lights, you don't want to go to the North Pole itself because you'd be too far north. So it forms a ring, and it helps us understand why we get the Northern Lights here. Because someone has mentioned the magnetic field. You might have played with a magnet at school. You might know they line up north to south and they attract to the others. And you might have done this thing on the right where you sprinkle iron filings, little bits of metal. around it. And so the metal then lines up and it traces out what's called this magnetic field line. And that field is why your compass, when you're navigating, points north, because the Earth itself is a big magnet. So your compass will point north. We just have to flip things upside down to get it kind of just right. But your compass points to the North Pole. Also then, the solar wind kind of gets funneled down and it forms these northern lights and southern lights near the pole. To understand why, so normally that's kind of going through countries like Greenland, Iceland, Norway, Sweden, and so on. But to understand why it comes down this far south, I'm going to do a little demonstration. I'm going to need a bit of help. Can I have maybe a beaver and a cub who knows some countries and is able to recognise some countries from the world? So, okay, do you want to come up? And we have a cub who, do you want to come up? About recognising countries. We'll have a bit of help with Mark as well. So, can I ask you please to come around? Sorry, what's your name? Lily, if you stand just in front of me here, and can you hold the globe? If you stand side on, actually you're going to need to come closer. How about if you stand in front of this camera here? Can you just come around here? Can you come around here and hold this? And your job, sorry, what's your name? Cedric. You've got a special job. You've got a hairband here, a scrunchie, that I'd like you to put on top, and that's going to represent the Northern Lights. And if I move on the slide, we can hopefully see, here we go, courtesy of Mark's cameraman duties. Can you point out, one of you, if I hold this, or if Lily can hold that, Cedric, can you point to the North Pole? Can you see where the North Pole is? It's there, yeah. And if we look around, can you see the kind of countries that underneath this scrunchie? Can you name, where's this, do you think? Do you know these?
South Pole.
The South Pole's down at the bottom. Do you know what country's up here?
America.
Yeah, that's Canada, and we've got, do you know that one? Iceland. And around here we've got other countries where you might see the Northern Lights. So now, if Lily can hold that, and Cedric, can you stretch the scrunchie? And if Mark catches this on camera, if we stretch it, what happens to it? What are the countries? Where are the countries it's now on top of?
Canada.
Say again, sorry?
Canada.
Canada, it's gone a bit further down. What about over here? Or Lily, do you know where that is?
Europe.
Europe, and down to the UK as well. So if we maybe bring this a bit along there, you can hopefully see as that scrunchie gets bigger, it comes down to countries a bit further down. And that's what happened. Thank you very much. If I take that back, thank you both. If you want to head back, and thanks, Mark. Round of applause for our volunteers there. That's why we get the Northern Lights further down, is because the Northern Lights acts like that scrunchie. Sometimes the ring gets bigger, and when it gets bigger, it comes down to us, and that's why some of you were able to see the Northern Lights here last year. Okay, so the final thing I just want to say is that part of the reason we study this, people like Susie and I study this, is to understand how that all works. But part of the reason that Susie also mentioned is that the same things that are causing the Northern Lights also have effects on technology, both up in space, like satellites, and also down on the ground, like power grids or communications and things like that. And as we have more and more technology nowadays, it's becoming more and more important to understand and predict what's going to happen. You might have heard of companies and organisations like the Met Office, who do our weather forecasts. For the last few years as well, the Met Office has started doing space weather forecasts to help companies that operate aircraft, satellites, power grids, understand what's going to happen and know what steps to take to look after their equipment. Okay, so it might well be in years to come. We have students going off to go and do space weather forecasting at the Met Office and the like. It might well be in the years to come. We'll be tuning some of you guys giving those kind of forecasts. Okay, so with that, I'll return to the picture, and thank you very much.
November Alpha 1 Sierra Sierra, November Alpha 1 Sierra Sierra. This is Golf Bravo 4 Romeo Sierra Sierra, standing by for a scheduled contact with the International Space Station. Over. NA1SS, NA1SS. Over. NA1SS, NA1SS, this is GB4 Romeo Sierra Sierra standing by for a scheduled contact with the International Space Station. Over. NA1SS, NA1SS, this is GB4 RSS. We have you in the noise, Johnny, so hopefully you will... Over.
Yes, sir, over.
Hi, I'm Leo. Is being on the ISS like living on Mars? Over.
You know, I don't quite know for sure, but I suspect it is. Living on the space station is like taking a really long camping trip. We are in an austere condition, just like camping would be. And I think being on Mars would be just like having an expedition for you guys.
This is Robin. Can you see the Milky Way from there? Over.
Earth, we can see from the International Space Station, but a lot more clear because we have a lot less pollution and atmosphere noise. Over.
Hi, this is Oscar. Do plants still grow towards the sun on the ISS? Over.
Hi, Oscar. Plants grow towards their nearest light source, and so that's not always towards the sun. In the International Space Station, it might be the nearest light bulb. Over.
Hi, I am Alice. What's the funniest thing that's ever happened to you in space? Over.
Oh my gosh, there are so many funny things that have happened to me. I think most of it has been funny pranks that my friends, my crewmates have done for me, like sneaking up behind me. Over.
This is Ruben. What happens if you drop something in space? Does it just float forever? Over.
Right now I've got nuggies for my kids and I'm dropping them in space and they will keep floating forever. Over.
This is Eric. Have you ever seen a spaceman or shooting stuff from the ISS? Over.
Eric, I've seen a lot of storms and shooting stars. Sometimes they happen so quickly that I don't even notice it unless I'm actually taking pictures and then I review the pictures later. Over.
Hello, this is Eddie. Have you ever had to fix something important in space and what happened? Over.
On the International Space Station as astronauts, not only do we perform science experiments, but we are also constantly fixing things. I'd say one of the most important things I've had to fix was the toilet, because that is very, very important. Over.
Hello, this is Felix. Do you ever play tricks or jokes on each other in space? Over.
Oh, yes, we play lots of jokes on each other. One time, I had my friends were hiding inside a big box, and I didn't know it until I went near it, and they popped out and surprised me. Over.
NA1SS, Johnny, we have you on HAMTV. Thank you very much for activating it, and I'd like to dedicate it to our colleague Gaston Bertels, who worked so hard to get it in space. So give us a wave, please.
What do you eat for breakfast in space? Cereal would float away.
Over.
Over.
Okay, I think the last question was, do I ever play tricks and jokes with each other? We do all the time, and because Halloween's coming up, I'm really looking forward to that. Over.
What do you eat for breakfast in space? Cereal would float away. Over.
I had breakfast. I had a tortilla and some breakfast sausages, and yes, cereal would float away if we let it. Over.
This is Sasha. How does a spacewalk feel? Over.
Hi, Sasha. I have not performed a spacewalk myself, but I have supported one, and talking to my friends who have done one, they're really hard, but we've trained a lot on the ground at NASA so that we're well prepared. Over.
Hi, this is Millie. Does food taste different in space? Better or worse? Over.
Hi, Lily. Food tastes different. It's just not as strong, which is why I use a lot more hot sauce and salt than I normally would on Earth. Over.
Hi, I'm Cohen. What is the coolest experiment you have done in space? Over.
The coolest experiment I've done in space is an experiment where we tried to see if we can grow more perfect crystals in microgravity. And the reason we're trying to do that is because it might make medicine stronger. And if we can do that, it'll help a lot of people on Earth. Over.
Hi, this is Alyssa. Do you feel dizzy when you get back to Earth? Over.
Yes, we feel very, very dizzy, and that's because our bodies get used to having no gravity. But when we return, all of the senses come back and our brain gets very confused. Over.
Hello, this is Lily. With Halloween coming up, do you hear creepy sounds on the ISS? Over.
The space station can be quite creepy. Space is very quiet, so it's easy to sneak up on each other. So I suspect a lot of creepy sounds will be coming near Halloween. Over.
Hello, this is Freddie. Do you play board games on the ISS? Which ones? Over.
Yes, we play board games. Actually, we played one last weekend, and we were playing Codenames, which is a fun, team-based game on trying to think of the other person's word. Over.
Hello, this is Lucas. What's the most difficult challenge you've faced while living on the space station? Over.
The greatest challenge I've had is missing my family. I have 2 little stuffed animals here, and they belong to my 2 youngest kids, and I miss them very much. Over.
Hello, this is Dylan. Do you have bedtime stories or teddy bears in space? Over.
Hello. Yes, we do have teddy bears in space. I've got my daughter's little dolphin here and my son's little lion right here in space. Hopefully you can see it. Over.
This is Cynthia. How many months can you stay in space for? Over.
Well, you can stay in space for as long as you wanted to. My mission is 8 months, and I've been up here for a little over 6 months. Over.
Hello, this is Mahika. How do you prepare your body and mind to live in space for so long? Over.
You know, just like with a lot of hard things, it requires a lot of focus, training, preparation, and good support network. I would say I've had a lot of help along the way with not just my family, but also my friends and the people I'm up here with. Over.
Hi, I'm Ethan, and can you drink hot chocolate in space? Over.
Yes, we can. It's one of my favorite things to drink, especially when it feels a little cool up here. Over.
This is Sihath. How do you stay clean without a shower in space? Over.
So we don't have running water in space, and shower is one of the first things I want to do when I return to Earth. But we do clean ourselves, and the way we do that is we get a towel and we wet it with some water and we rub it around against our body. It's kind of like a scrub bath. Over.
Hello, this is Sophia. What training do you have to do to be an astronaut? Over.
You know, there's a lot of training, language training, flight training, learning how to use the spacesuit, learning the engineering. But I would say the most important thing to being an astronaut or just successful in life is just having a curiosity to learn. You're never too old to learn something new. And if you remember that, you can do anything that you put your mind to. Over.
NA1SS, NA1SS, this is GB4RSS. Johnny, thank you very much. That was absolutely fantastic, and thank you for all your efforts to get HAMTV operational for us. Everyone here wants to say a big thank you. So, you ready? 3, 2, 1.
And welcome back to the afternoon session of CAT25 Part 2. And thanks to all of you who joined our ATV packed lunch. And special thanks to Noel G8GTZ for organising the ISS contact footage from ARIS for us. Our next presenter is Phil M0DMY, who first joined the ARIS UK operations team in 2016 to assist with AV production and has helped with ARIS HAMTV reception for UK and worldwide contacts since 2017. Since 2018, Phil has also worked on the QO100 and other Goonhilly webbed SDR facilities and served on the BATC committee to maintain the club's web infrastructure. Well, later he'll be giving advice on filtering out adjacent band RFI on HAMTV. But first, Phil is going to give us an introduction to HAMTV on the International Space Station, talk about a typical ground station for reception, and show how they use a network of ground stations to support educational contacts. And a reminder that if you're watching this live, you can ask questions and make comments at any time on the BATC and YouTube chats. And now, welcome to Phil. Hello, Phil.
Good afternoon.
Good to see you, and we're looking forward to your talk this afternoon. Over to you.
Thank you. So I'm going to talk a little bit in this one, as Dave said, about the HAMTV itself, the typical ground station that you might put together to receive it, and also about the TS merger, which is the software at the core of the network of ground stations. You saw a bit, you may have seen a bit in the ARIS contact there of the HAMTV in use on the contact last weekend. I'm going to start with an introduction of what is HAMTV. So the HAMTV transmitter, which is the box that we're actually talking about, is the blue box in this photo on the right with Samantha Cristoforetti. So this is a TV transmitter that runs in the 13 centimeters band, typically on 2395 megahertz. It has a couple of frequencies it can switch to as options, but 2395 megahertz has been the one in use since commissioning. It has about 2 watts output at the feed. I believe it's about 5 watts out from the unit itself, and then there's filters and coax in line, which push that down towards 2 watts, maybe even a little bit lower to the antenna feed on the outside of the module. It transmits 2 megasymbols per second dBs. Again, it can toggle to a different mode, but 2 megasymbols is the one that we use with half FEC. The inputs on it, this is quite an old unit, so it's NTSC analog video and an analog audio input. The NTSC analog video was designed for compatibility with the cameras on the space station that were there at the time. They are now in the minority. In fact, I believe there's only 1 camera left on board that has NTSC video out because they're all 4K HDMI units now. However, the ARIS has launched a HDMI to composite converter up with a test card generator that we're hoping they're going to press into service in the next few months once approval is completed. The encoding then on the DBS is also quite old. It is MPEG-2 video and MP2 audio. Within the roughly 2 megabits that we get through that DBS channel, we've got about 1500 kilobits of video, sometimes slightly more, and then the audio has been shrunk down to 64 kilobit per second. This is a reduction from what it used to be. This is recent. This is a reduction from what it used to be in 2017. We used to have quite a lot of bandwidth on the audio. I think it was 250 kilobit or something. But that has been reduced to allow the video quality to be improved, and there is a noticeable improvement on that. This does have the advantage that the audio, the disadvantage that the audio, particularly with the noise in the modules, can be quite poor, and so sometimes the VHF can sound better. Next, I'm going to talk a little about the history of this transmitter module. This project really starts with there was a fundraising campaign started from 2005 to raise funds for the S and L band antennas that were then installed on ESA's Columbus module. just before launch in 2008. The HAMTV transmitter was then built to use these antennas for the S-band downlink. And in 2013, in August 2013, this was launched to the Columbus module on a Japanese cargo mission. It was then first commissioned in March 2014. There were a number of tests done at the time. And then in February 2016, we had its first use in a HAMTV contact. So this is the photo on the right here. This was one of the Tim Peake contacts that we did in 2017. And this was the first time that we'd had camera video during a contact through the HAMTV unit. That was thanks to Tim Peake, who was actually up for several hours beyond his scheduled bedtime, looking for the particular cable that was needed to plug the camera into the transmitter. But he sent Kieran an email late at night to say that he'd found it and that we were ready for HAMTV the next morning. Tim was then very keen to make use of the camera during the rest of his contacts while he was up there. And he also helped encourage other astronauts to agree to plug the camera in as well for their contacts. So we had Thomas Pesquet, Jack Fisher, and others started to make really quite regular use of it. Unfortunately, then in April 2018, the transmitter failed. You'll probably find some correspondence about this on the BATC forum, where we were trying to work out what was going on and looking for reports. But there was just no RF output observed from the transmitter. They tried rebooting it and all the normal steps, and that didn't work. Due to some of the budget limitations on the project to build this transmitter, there was only one ever built. So there was no spare, no engineering model. And so the only way to get this back working again was to bring that only transmitter back down to Earth. This isn't usual for ISS equipment. Usually it's far cheaper to build a new one and throw the old one out. But in this case, that same unit was returned to Earth, returned back to Kaiser Italia, who then, following repairs, and they made a couple of changes, including to the video bitrate. This went through approvals again. There were some more stringent RF requirements this time, which resulted in an extra filter having to be added to the transmitter output. And then it was relaunched to the ISS in March 2024. On relaunching it to the ISS, there was then an issue with how crowded the modules are getting nowadays. Someone had taken the space where it was originally installed due to a mistake in the space allocation. And so then there was quite a delay while that was worked out. But finally, thanks to ongoing efforts particularly from the ARIS USA team, in July 2025, it was finally installed in place in the Columbus module and powered on, and immediately came up with a very good signal. So on the use of HAMTV, as you may have seen in the contact video just now, the ARIS contacts historically use VHF, UHF, FM for voice, and actually we will continue to do this. This provides a good analog feel. You heard the astronaut's voice rising out of the noise as the space station comes over the horizon, and we find that really actually does add to the build up of the event. Although HAMTV has audio, we don't use it in contacts, partly because there's still a bit of a video delay on it that we believe is partly in the transmitter, although we do have some delay on the ground as well. The HAMTV is there to provide the additional facet of the live video alongside the voice questions. And as you may have heard, Kieran asking for a wave, and the kids do enjoy that, being able to wave to the astronaut as they wave back, as you can see in the photo there of another Tim Peake contact, the bottom one, with the primary school kids waving to Tim as he waves back. The astronaut can also do visual elements. You may have seen in the video at lunchtime, the stuffed toys floating around and the astronaut actually struggling to keep track of them alongside talking. on the radio, but they can also, of course, float upside down. Tim did this in one of our contacts where he very slowly floated upside down and then seemed to realize he was upside down and correct himself, which caused a laugh on the ground. The technical aspect as well, we've got the Yagis for the radio, for the VHF, UHF radio side of things, and talking about that with the students or with the audience is a good way to bring the students into radio and amateur radio. And this provides another aspect to that. So we've got a slightly different looking antenna. We typically go with the dish antenna, I'll talk about later. And that's another technical aspect that we can talk about, and about how that works and about how this relates to the sky dish on the side of your house and that kind of thing. So the current transmission from the ISS, so the transmitter is currently on. I've seen some reception reports of it just this morning. The one major change from last time in 2016, 2017, if any of you received it then, is that sync detection has been added to the video input board. And this means no blue line and no audio hiss, which has actually made testing quite a bit more difficult. It's also digitally a lot cleaner, but it does mean that there's absolutely nothing to see changing or hear at all. So what you'll see is on the left, you can just about see that VLC window, it's just black. The aspect ratio last time was 4:3 incorrectly. That has now been fixed to indicate 16:9. So you'll see that VLC automatically goes to 16:9 when you pipe it in. The resolution reports as 352 by 480. We were a little worried about this, but the video quality actually looks really quite good from the contact last weekend, particularly quite good in relation to the MPEG-2 from 2017. And we still think there might be less horizontal resolution, but that combined with the up in bitrate means there's almost no compression artifacts. There's far less compression artifacts to be seen. And so this looks to be a good change. It comes out 16:9. And so we're happy with this. The other thing to see, so the other key change that was made with the transmitter since 2017 is the program tables have now been added. So you can see in the VLC screenshot on the left there that there is HAMTV program 1, publisher HAMTV prog. The program tables and some of that related metadata wasn't there in 2016. It had been removed. And that prevented being able to receive it on a common satellite set-top box. They've now put that in, and it's now been tested that you can receive it on a standard satellite set-top box with the right setup. So that's a bit about the transmitter itself. The antenna that it's connected to. So I mentioned the L and S band antennas that are connected to the outside of the Columbus module. These photos are both taken Earth up, so upside down. That's just the original aspect of these photos. So on the photo in the left, you can see the beige panel or beige object that's underneath the orange arrow there, and another one to its left. These are the two L and S band antennas. The one that HAMTV is connected to is ARIS41, which is the one on the right, the one indicated by the orange arrow. Now, there's quite a long cable to this, and the cable also goes through a vacuum interface connector that is not an RF impedance matched device, and that's why we estimate that there's actually quite a low amount of power at the antenna. But as you can see, particularly from the photo on the right, there's no real blockage around it. The free space path to the ground is pretty good. Although we do occasionally see blockage, and we reckon it's from those solar panels because it's particularly on passes that are a little bit lower. Those solar panels will occasionally block certain ground stations from receiving it, and this is one of the things that kicked off the ground station network, and is part of the motivation behind the ground station network. The other thing that we can see here is that the antennas are about half a panel back from the nadir of the spacecraft, so the bottom of the spacecraft. This means that they're angled about 15 degrees backwards behind the ISS. And this is notable from when you're trying to pick it up at low horizon. If you have a high performance ground station, you're lucky enough to have a low horizon and you're waiting for it to come up over that horizon, you won't really, or in our experience, you won't be able to decode it until at least 15 or 20 degrees, because you're still looking at it from effectively behind the module at that point. Once it gets to about 20 to 30 degrees, the signal strength picks right up. And then with a high performance ground station and a low horizon, it is decodable right the way down to the horizon on the descending side. So the pass is asymmetric that way. Moving over to talk about your typical ground station. So this is a rough block diagram of how we put together a typical ground station to receive HAMTV. So you obviously want an LNA to reduce your noise figure. You want reduce your system noise temperature, sorry. You will likely need a filter. I will talk a bit about that separately, a bit more about that and some of the experiences we've had. That filter probably wants to go before the bulk of your amplification for reasons I'll also talk about later. So another line amplifier, a cheaper, higher noise amplifier after the filter can work quite well. You can then optionally down convert, and there's a couple of down converters that are available for this. But also the mini tuner supports 2395 megahertz natively. Some of the SDRs support 2395 natively. So you don't have to, but if you've got a long coax run to your shack, then of course it makes the loss a lot easier to deal with. You've then got some kind of receiver that I put it into a PC here, but as I mentioned before, a satellite set-top box into a TV is also functional. And then a pointing mechanism. So typically we go with motorized pointing systems, for example, the Yaesu ASL systems. Some people have DIY systems. It is also possible to point it by hand, and that's something that GHGKQ actually used to do on a small dish, and that's totally possible. The main disadvantage is you can't do anything else while the pass is going on because you're trying to keep track of it. And so if you want to be able to test other things and watch the video or such, then it's useful to have some motorized automated system. On the pointing side, the big thing that matters here is the size of the dish. So there's quite a push generally for people to try and get the low elevation performance and to go towards the larger dishes in order to do that. So I'm going to assume here that you're reasonably aware of the satellite orbits and about how the spacecraft, when it comes over the horizon, is a very long distance away, but then that distance drastically reduces. So you can see here at, so I'm starting here with a reference point of a 0.9 meter at 90 degrees elevation. An MER of 12 dB is easily achievable, which given we're using FEC half dBs, we only need 1.7. Okay, you want quite a bit of margin on that, but you still got 10 dB of margin over that at that point on a 0.9 meter dish. As you go down in elevation, that path length to the spacecraft dramatically increases, but you can see there at 20 degrees elevation, you've still got a bit of margin. I'd say that 2 dB is about the minimum you want. But you may not have a 20-degree horizon at your QTH. I certainly don't here. I'm more at more of a 30-degree horizon here, particularly as the signal doesn't go nearly as well through trees and such. So even though you may be able to hear the VHF down to a lower horizon through the trees, you likely won't be able to receive the HAMTV through it, even with a large station. When it gets down to really low elevation, obviously you then do need something far larger than 0.9 meters. But as you get larger in dish, so the pointing requirements also become a lot more severe. So for a 0.9 meter, like that example in the photo there, you're plus or minus 4.5 degrees for the 3-degree beam width, which is quite achievable with a bit of care and calibration. I put there that the G5500, if you check the data sheet for it, it says plus or minus 4% on azimuth pointing, which is plus or minus 14 degrees, which is obviously way out of this. However, with good calibration of the pointing, lining it up well enough, you can achieve far better than that. And I achieve about plus or minus 2 degrees off a G5500 system. As you get down towards 0.6 meter, so you can with a 0.6 meter, you can still get off the top of my head anything above 45 degrees, you're going to be able to receive no problem. And that's plus or minus 7 degrees, which is actually quite a bit of the sky. And that's where handheld pointing, mounting it on a tripod, or even with a helical antenna of similar gain, you can quite easily hand point it within enough accuracy to be able to get the good decode. On the G5500 accuracy, alternatives such as SPID systems do exist with higher accuracy, but the cost really does start to go up quite a bit at that point. System noise figure, as we look at the RF chain, is something to keep aware of. So this pictured chain here, or the NOELEC special, as we've come to call it, is one of the ones that tends to get asked about as to whether it's suitable for use. So these three products are all available for NOELEC. You've got their wideband LANA LNA Hammett down converter, which has a 1.5 gigahertz LO, and that brings the 2395 down to about 900 megahertz. And that puts it in the receive range of the NOELEC RTL SDR, such as an RTL SDR V4 or such. And on the face of it, this looks great. However, the LANA has only a 12 dB gain, and the Hammett down has no active gain in it and has a 12 dB conversion loss. And you're adding that to any cabling in the chain, because you're probably not putting the LNA, probably not putting the RTL SDR at masthead, and then the noise figure of the RTL SDR as well. And you end up with, even though you've got a 2 dB noise figure on the LNA, your system noise figure is actually well over 5 dB. So at this point, you're going to need an intermediate gain stage. Something with a higher noise figure is totally fine after the LNA, just to provide that additional gain before the loss of the down converter. Some down converters do have gain stages built in order to get around this, but the Hammett down particularly doesn't. The example that I've given here, so where a 20 dB, 5 dB noise figure, which would be 10 or 15 pounds off eBay, reduces the noise figure by about 2.5 dB, which is the difference between a 1.2 meter and a 0.9 meter dish, just in how you've set up your RF chain there. Unfortunately, adding gain does also cause some issues. So the particular problem we deal with is RFI. Now, this was quite an easily manageable problem back in 2016, 2017, when we were dealing with Wi-Fi, and Wi-Fi was the main issue. So there was a lot of making sure that when we went to venues, making sure that they moved all their access points off channel 1, so that we could then use some cheap filtering to remove most of the power there. And also looking out for any malfunctioning access points that were transmitting below 2.4 gigs, which it turns out, exist. This has changed slightly now in the UK. We now have the 4G band 40 owned by Telefonica. They purchased this in 2018. There was a good bit of consultation on it, which the BATC and RSGB were involved with. And you can see that on the left of this screenshot from Graham G8FXB, that the amount of solid power in that is significant. So whereas Wi-Fi was a bit of an intermittent signal, it would peak up on the SpecAN depending how much iPlayer people were watching. This 4G is constantly on. It's constantly there. It's quite a constant power envelope. However, it is a high power envelope. And you can see that's 5 dB per division there. The purple trace or pink trace, or it that you can see directly in the middle, is about a 6 dB signal to noise HAMTV. So it's a little bit weak, but not too bad. And that compared to the size of the 4G that you see here. This means that you need a high dynamic range in your system, because if you're padding down your system to be able to deal with that power from the 4G coming in, you can quite easily then lose HAMTV into the noise floor. This can be difficult. I've had to swap out a couple of amplifiers on mine because they haven't had enough output power without compression to be able to deal with this. And I've also been looking into filters quite a bit for this, and filters really is the first solution. And I'll talk a bit about that later. On the receiver side of things, we've got the mini tuner, which will be familiar to nearly all of you on the left. This is the ideal receiver for it. It works extremely well, copes with the Doppler, all this kind of thing. Since 2017, one of the new things is there's more software available for it. We've done some testing of the software around, and the best software that works the best is SatDump, which is pictured on the laptop on the right. So on the right, this is a photo of me receiving the ISS on a 0.9 meter dish in my back garden with a Hamit down and an air spy that you can see on the right there. And this is receiving a good, I think that was 11 or 12 dB MER. With the SatDump software doing all the demodulation in software there. The software receivers do tend to be quite a bit more sensitive to overload and such, particularly from the high RFI levels. But with attention to that, they really do work quite well. Some other examples of ground station constructions here. So you've got the full dish on the left there that I was using the SatDump. So that's a 0.9 meter offset. I've got mounted sideways because it makes calibrating the elevation a lot easier. And that on a G5500 mount. The IK1 SLD Claudio in Italy at his Telebridge station has this unit, which I believe was part of the original batch of ground stations that were set up for HAMTV when it was originally launched. That's a 1.2 meter offset. You've got GHEKQ's first iteration of the hand-steered 0.6 meter there, and we used this quite successfully when we were first exploring HAMTV. You can just about see the spanner on the left hanging down that was used as a not a pendulum, can't remember the right word for it, but was used to measure the angles so that we could look that up against a printed out lookup table to see where we were meant to be pointing. And that worked quite well. On the right there, you've got at the other extreme end of things. This is the antenna that we have temporary use of for the contacts down at Goonhilly. This is a 5 meter S and X band antenna, which works very nicely. However, it still suffers from the blockage, so we still sometimes don't have signal at Goonhilly, where we do have signal with someone with a 0.9 meter antenna. And we believe that's due to blockage from the solar panels. So even with Goonhilly in the mix, there's still a requirement for more ground stations. On the operational side of this, so I've talked a bit about stations at home, how we use this at schools with the contacts. So for Tim Peake's Principia contacts, we use Knowles Land Rover here, which I believe Mike currently has, and this was set up outside the schools with the 1.2 meter ham design mesh dish on top. Noel has actually done a full talk about how he calibrated the pointing for this and his particular way of parking the Land Rover, assembling the G5500 in a certain orientation, so that he could make sure that this was pointed and set up in the typically 24 hours that we had from arriving on site to make this work. We then had issues with RFI, particularly from Wi-Fi, sometimes from malfunctioning Wi-Fi access points as well that were transmitting on directly to 2395. These had to be tracked down, found, and pulled out within this 24 hours. And this is combined with all your standard portable station challenges that many of you will be familiar with, of finding out you brought the wrong cables, your connectors come off the end of the cable, or trying to set this all up in the rain without anything getting too wet. And of course, although we all enjoy the technical challenges of this, the key thing here is for the participants and for the audience to get that HAMTV experience. So even if we've had a great time setting this up and solving lots of challenges in the setup, the key thing really is that we have that HAMTV experience for the audience at the contact. So the first way we did this was to get everyone, to get a bunch of ground stations to stream what video they were receiving to the BATC merger, sorry, BATC streamer even. And Noel, GHUTZ, put together this page on the left of all the old Flash streamers put together. We assigned people a channel to go into. And then we would do manual switching of if X had a better, less glitchy stream than the current one we were looking at, then we'd close the current one, open the other one over the top of that, and switch between these. And this worked reasonably well, particularly when a ground station would totally lose it. We could then switch to another one that at least had a partial copy. But it did involve this manual work. We ended up sometimes with different delays between each of them, which could be a bit disorientating. And also we started to think about whether there was a better way of combining all the video information that we were receiving. And this is where Phil Heron, MI0VIM, started looking at the MPEG transport stream and working out whether we could combine this at an MPEG transport stream packet level. So MPEG transport stream as used by HAMTV has 188 byte packets. Some about 1 in 50 packets have a PCR timestamp. So this is generated from 27 megahertz clock. But we can use this timestamp to synchronize the ground station feeds. We can have 100 millisecond delay buffer that we wait for the streams to come in. And then we can pick one of the PCR segments from a particular station and output it. And then when the next PCR timestamp rolls around, pick the next segment from a ground station. And then we can switch between those ground stations based on the segments. It would be ideal to switch on a packet by packet basis, but the continuity counter that's used to clock the individual packets is both done per PID, so it's not uniform across the packets, and it also only has 16 values. It goes 0 to 15 and then loops, which means within a 50 long chunk, you can't actually uniquely identify the packets within that. So the only reliable way we've found to do it so far is using this PCR timestamp and switching within segments of that. So we then put the infrastructure together for this with the support of the BATC. And this is an example of it in use. This is on a contact by Jack Fisher. This was actually a contact being done in the States, but due to the orbit, the ISS was not over the States in waking hours. So we used the telebridge in Europe for the VHF, UHF. And we had ground stations in Europe that were receiving into the HAMTV merger. And then the venue that I believe was at one of the large mission control halls in Texas looked at the output of the merger, and they had the output of the merger there on the screen behind the questioning taking place. You can see on that screenshot there that we've got Green Hilly receiving. That was with our old 3.7 meter dish that we were using at the time. We've got my receiver that was down in Southampton. That was the offset 0.9. We had Jean-Pierre in France receiving, and we also had Wouter receiving in the Netherlands there. So this infrastructure was then also used for contacts with Paolo Nespoli and Thomas Pesquet as well before the transmitter initially failed. Looking at the contact last week and what we used for that. So this on the photo is the picture outside of the venue. So the video that you saw was inside that tent that you can just see a slither of through the door there. South was down to the left of the photo. So the antennas, the VHF, UHF antennas are pointing north in this case. And on the right-hand side there, you can see the small 0.9 meter prime focus dish that I took along to provide the HAMTV. Now, this wasn't a high-performance ground station. The idea was that we had the high-performance ground stations at other venues that were well set up, have been well established, feeding the merger. And this really was a backup station for if we had internet issues, which we actually did at the start of the contact. And also to provide a technical thing on site to talk to the audience about as well. So looking at this structure of how I had things set up for that contact, you've got the typical components of LNA, filter, and line amplifier. I'll talk a bit more about the particular filtering I used in the next talk. Inside that equipment box next to the dish, I then had an RF splitter feeding both a mini tuner and a Pluto SDR. The mini tuner was the prime receiver chain for this, so I was running Longmind on a Raspberry Pi, which is the same software used in Ride and in Portsdown, effectively the Linux version of the TwoTune software. And this was feeding the TS merger along with all the other ground stations. But I also had a direct feed into a dedicated player as well. And this was so that if we had internet issues, then I had a totally independent route that we would be able to receive some HAMTV with. For playing this, I use a Raspberry Pi. This is Raspberry Pi 3 to play the MPEG-2 video, because the Raspberry Pi 3 is the latest Pi with an MPEG-2 hardware decoder. The MPEG-2 hardware decoder copes a lot better with the glitches. It just shows a glitch and moves on, unlike VLC and other players that tend to stall whenever they receive a glitch. And so I still find this is the better way to do this. I could talk more about that, but that's probably a whole nother talk in itself. This was feeding the two TVs at the front. The idea was I could switch between the two Pis. That was a case of unplugging one of them and plugging the cable into the other, which I did at the start of the contact due to the internet outage, but then we ended up swapping back, and I don't think any of it was output to the TVs at that time. In addition to the mini tuner receiver, I also had a Pluto SDR in there. The main reason for this was being able to see what was going on RFI-wise. We had a lot of issues with RFI, and being able to see the waterfall gave a good idea of what was going on there. So this is a screenshot of the reception at the Warwick venue. This is the Pluto SDR feed on the right-hand side, piping over the network and then decoding on the local laptop. And then on the left-hand side, you can see GB4 RSS, which is the mini tuner feed from the venue, and also Goonhilly receiving. This was the blank pass at 7:30 a.m., the first pass of the day that we got up early and got in for. The display then, so this on the right was my desk during the color bars test pass, which was the next test pass, an hour and a half before the actual contact. On the left-hand side there, you can see the two Raspberry Pi cases. Those were the two media players, ready for me to swap the cable between them. I've got a preview of what they're showing on the left, and then I've got the laptop on the right with a remote desktop to the Goonhilly station, and you can see the merger in the background with all the stations active as well. Contributors to the Warwick contact, I'd just like to acknowledge that we had everyone who'd so far been qualified for contributing to the TS merger. So we had GHEKQ in Salisbury, we had Claudio in Italy, we had Leo in Czechia, we had the antenna lent to us by Goonhilly Earth Station in Cornwall, and then we also had Von Storch Engineering in the Netherlands lent us their commercial antenna as well. We did see some issues in the past last weekend. Particularly, there were more discontinuities, more glitches than I expected to see in the output. I've been looking at this more recently, and I plotted the PCR clock values. You can see that graph on the right-hand side, and you can see that although we've got a generally increasing line, there was also some erroneous values coming through as well, which really shouldn't be the case. And this fed into a player. FFmpeg coughs out errors when this happens and stalls the feed. And I think this also caused issues for the Pi players on site because it wasn't a glitch so much, it wasn't lack of data as much as corrupt data. We were already filtering for having the correct MPEG header on the front. So this was errors in the data part of the MPEG, which would have really confused the player. In looking through this, I found that they were seen from sat dump SDR receivers. And it was particularly notable. The first couple of glitches there are actually from the sat dump receiver at Goonhilly. And the last set of glitches, lots of glitches there, are from one of the sat dump receivers in Europe. And in looking into this, I found that sat dump doesn't actually filter out the frames where Reed-Solomon reports that it's been unable to correct the errors. I understand that when you're building up a weather satellite picture or something, you want data in there, even if it's noisy. But for us, it's harmful to the merging process. So I'm currently modified a local version to filter out those, to filter out any frames where the Reed-Solomon reports that it's been unable to correct errors. And I'm currently testing that out with an option button added to filter out these. And then I'm going to try and get that merged into the upstream version. And then we will insist that people use this with this option enabled for contributing with SatDump. Just a quick shout for volunteers towards supporting the TS merger for future contacts. Suitable receivers are Minitune or Portsdown, and also SatDump. We are going to get that issue resolved so that contributors with that can continue to be involved. You do have to use a DVB push bit of software. This is the bit of software you can see on the screenshot in the right, on the screenshot on the left in the right. That takes the MPEG, it wraps it up into some batches, which avoids some internet router issues. And it also puts authentication headers on it so that we know who the transport streams come from. And as you can see, that's been quite useful in tracking down errors. We have an onboarding process where we'll talk to you about your internet connection. That tends to be the key bit that we care about. And to have a look at the error rate on your upload and help you with issues if you've got any issues there, so that your contribution, so that we can make the most of how much you're receiving with your antenna. And just a few links on here. I realize I'm running quite tight on time. We've got links on the streaming there for the main contacts. There's also a separate page with the TS merger output. You can see which stations are contributing there. We're still playing around with what data is available. The signal to noise is not available from all stations. We're working on that. And we've got quite a bit of documentation we've been assembling on the wiki. There's several linked pages on there with different articles about ground station construction, typical issues, and contributing to the merger. And lastly, ARIS has set up a dedicated Discord server, to which there's a link there. You can also find it on search engine. And we have a dedicated HAMTV channel in there, where quite a few of us are often online and can answer any questions that you have. Thank you very much.
Lovely, lovely, Phil. Thank you very much for that. So much involved. What occurs to me is that you've been doing this for some time now, the UK ARIS team, and you're obviously still learning, still developing, still improving, even with all the technology that you've got. I must admit, I didn't know that you were using now a series of ground stations to contribute, but it does obviously allow for much longer contacts. But as you said, if the internet fails, you've lost it all. So you still have to put an antenna up there. We are running quite late now, and as there have been no questions so far on this, I think what we'll do is we'll round any questions up for the later session we've got with you after Jen's, and then if there's any questions then we've got rather more of an open-ended time. I just want to ask one quick question, if I may, though, Phil, and I think some people may be interested. Do you know what went wrong with the original transmitter that went onto the ISS? Did they actually say what had failed in it? Because obviously we're not used to having equipment up in space, and it's intriguing to know what failed.
I can't recall exactly off the top of my head. My recollection is that it was some faults with the encoder board. It's professional grade equipment, but it is not space grade equipment. It's not radiation hardened or anything. So my recollection is that it was something to do with a flipped bit in a flash memory somewhere. and so that left the encoder board unable to boot. And if I'm correct in that, then I've swapped out the flash memory in order to recover it.
Lovely. Okay, I have actually got one question. I will break my own rule and just ask you this because it'll all wrap up later on this afternoon. This is from Russ G4 SAQ. Is it feasible to down convert to say 70 SEMS directly after the LNA and then filter it?
As long as your down converter, any gain stages in your down converter can cope with the large amount of power or RFI that you might have, then yes. Yeah.
Okay, lovely. Well, thank you very much indeed for this, Phil. In a moment, we'll be meeting Jen to talk about a taster receiver, and then we're going to see Phil again later on to talk about filtering and things in more specific way. So we'll join you again in a few minutes' time. Thanks again, Phil.
Thank you.
Welcome back. Jen G4JIZ is a former BBC and space systems engineer and has been an ATVer for around 10 years. Well, she's now going to give us an overview of her first experiments towards reliably receiving ISS HAMTV signals, which involved characterization of the reception requirements and putting together a basic receiving system whilst taking into account the interference environment. And as I said earlier, also Phil will be joining us after this to talk about how to mitigate some of those filtering issues. But good afternoon and welcome to you, Jen.
Hi, yeah, it's G4HIZ actually. But anyway, good afternoon, everybody. I just thought I'd give you some benefit of my experience and hopefully get you encouraged to do something as well. As soon as the transmissions restarted on 29th of July this year, I set myself the target to receive it as soon as possible in whatever way I could. But I said to myself, actually, before I splash out on an expensive or time-consuming positioning system for an antenna, because ultimately I'll need to track it, I need to characterize this system and basically, you know, make my RF side of the system work first. So this basically covers my experience receiving the ISS signal so far, and indeed using the simplest possible method, and also the experiences I had along the way. So I'm going to cover a few topics, I think, which can help to people to understand the task at hand, including looking a little bit at the orbits we've got, downlink parameters, which have already been mentioned by Phil actually, but doesn't hurt to recap on them, basic receiving system requirements, and what you'd need to do then to actually make a tracking system. So let's just to recap then, the ISS is a low Earth orbit platform. It really is a low Earth orbit satellite. Altitude is about 420 kilometers, which is quite low. It's on an inclined orbit, 51.6 degrees, and it goes around the Earth in roughly 91.5 minutes, so very fast indeed. All these parameters will vary with time, though, due to things that influence the actual spacecraft's orbit, things like the pull of the sun and solar wind and stuff like that. So the actual parameters are available every day in an updated form. We call it the two-line element set, and there is a web address there that you can use if you wish to see them. So let's just see what happens. So the ISS is actually moving across the sky at quite a rate of knots. And if you look at a pass during sunset or sunrise, if it's lucky to coincide with that, you will see how fast it actually moves. And ultimately, you will need to track that. However, depending where you live, of course, the ISS may pass directly over you, or it may not, because unfortunately, given the inclination of the orbit, 51.6 degrees, the more northerly in latitude that you go, then the maximum elevation of the ISS will decrease until you get to a certain point where you can't actually see it, unfortunately. But we're quite favoured in the UK in that respect. And the high elevation passes are best because these are longer and they last 7 to 8 minutes. So this gives rise to the HAMTV merger project, which aims to stitch together these short passes to give a longer continuous period, as Phil described. What I've done here, I've tabulated a few places for which the maximum elevation has been calculated, and you can see it varies a bit. Of course, we're lucky in the London area. Further north you go, Edinburgh, for example, it never really comes above 39 degrees. So, you know, it can vary quite a bit. Another example I looked up and didn't put on the table was Bergen in Sweden, and that actually is only 19 degrees, unfortunately. So I'm just going to recap on orbits and things because we're used to the QO100, and the QO100, of course, is a geostationary satellite. It's situated above the equator, a long way out, 35786 kilometers above the equator, in fact. And in fact, we're looking for your Earth station, it's more like 40,000 kilometers. And this is as compared to the ISS, which is a low Earth orbit thing, and at 420 kilometers roughly, and it really covers a very small area indeed, indicated by that small circle. So that's the big contrast between them. Okay, how do you find the pass information? Well, I actually use a website called Heavens Above, and I've tested Heavens Above information they provide relative to that used by Goonhilly, for example, and they're spot on. So they're very, very similar calculation in the background. And this site is hosted by DLR, GSOC, in fact, which is their operational arm, which is the German Space Agency. So I've got a lot of respect for that information. It's quite easy to use. You simply put your location in, nearest city will do. You don't have to put the exact details. And choose ISS, because there are lots of spacecraft that it can give you predictions for, and select all passes. Otherwise, it will just tell you the visible ones, which you don't want to know. You need to know when it's coming over. And then that will produce a table for the next 10 days worth of passes, which you can then use to plan your monitoring of the ISS. Okay, so again, just to recap on these downlink parameters, for me, I think the most important thing here is the transmit power. And Phil showed that the antenna is mounted on the, where the antenna is mounted on the ISS. But I think that there will be some variation in the power that you actually receive, because quite simply, you have to take into account the radiation pattern of the antenna itself. So you may get less power on some passes and more on other passes. But I haven't found any great difficulty with my simple system just yet. Okay, so the starting point for me as a space systems engineer is to actually look at the link budget. And the link budget showed me that if I had a 90 centimeter dish and the ISS was directly overhead, I should get a pretty good C over N. The initial calculations were showing up to the order of 15 to 20 dB. But then again, you know, that was it's an estimate. The link budget takes into account the power of the transmitter on board, the free space loss, that means based upon the distance between you and the ISS, the characteristics of the receive system in terms of gain and noise, and the bandwidth, of course. Anyway, so I thought, well, why not try using a 90 centimeter dish, simply pointing directly upwards and wait for the ISS to pass. The 90 centimeter, of course, it benefits from also having quite a wide beam width, so you're more than likely going to actually see it. And I had an old 90 centimeter dish with a potty that I had previously used for QO100, and I use this for ISS reception. Fortunately, the polarization requirements for the potty dish combination are exactly the same as the ISS as we used on QO100 for the uplink. So first of all, I did it in two methods. I tried two methods. I had an S-band LMB available, and I think I bought this several years ago, just before the previous set of transmissions stopped, and then they stopped, so I didn't get to use it. Now this S-band LMB, I thought, well, give it a try. So I connected it direct to the potty and linked it back to the shack on a standard satellite TV coax, which is quite okay, the IF frequency only being about 1555 megahertz. And at the shack, I then split the signal so that I could see the received spectrum on a spectrum analyzer. So here's a block diagram of the setup that I used when I had the LMB. You can see it uses a high side DRO, which means that you get spectral inversion, in fact, but the system can take care of that. You don't see any problem whatsoever. It is a DRO as well, and quite commonly these things have quite a wide frequency sort of on them, and this one was about 200 kilohertz, too low generally. But again, you just set your receiver up to take that out. Okay, so LMB straight into the potty, down the coax back to the shack, through a splitter, mini tuner to display, sorry, mini tuner to receive it, and a display afterwards, various methods I used, and a spectrum analyzer to look at the spectrum. So this is the realization in my back garden. On the left-hand picture, of course, we have the LMB simply tie wrapped to the support of the dish. Short piece of semi-rigid going straight onto the potty. You can just see it there. Trying to keep the losses low before the LMB because you don't want to degrade the noise figure. And it was sitting on an old metal frame which used to house a hi-fi cabinet, but it makes a nice frame to point straight up. In fact, if I put pieces of wood under it one place or another and actually put a piece of an angle on it as well. Anyway, the idea was to look at passes that were nearly 90 degrees. Just to focus on that LMB in case anyone is interested, they are still available, so simply search on Google with S-band LMB and you'll find it. Last time I looked, about £70. The thing about it, they don't mention on here what the gain is, but in the advert it tells you about 55 dB. And I did measure the gain of my one, and it was just over 55 dB. The input frequency range, though, is quite wide. You can see 2.3 to 2.9 gigahertz. Turns out to be an issue. Okay, so this is a photograph basically taken of me receiving the signal. Got quite a good spectrum on the right-hand side, and we're displaying using the Minitune software on the left. Typically, we've got the black video, which unfortunately that's what we get these days unless they're doing some sort of lineup. But good reception, D14 indicated. However, so summary of results on, oops, what we got here? Yes, here we are. So it was a success in that we could receive the signal, black video, of course, but we experienced dropouts. And what that meant was that in the period across the sort of 18 seconds that you may have received the video, literally the D number would drop dramatically and then come back again within a second or so, which wasn't really very useful. And the suspected issue there was due to the wide input frequency range of the LNB, because we've got Wi-Fi, of course, to 2.4 upwards, and 4G, as Phil pointed out, on the lower frequency side. I do have a video here, but I can't actually show it this time, unfortunately, but I'll pass on. So, next stage then, how do we get rid of this dropout scenario? So I decided to adopt, which seems to be the standard approach these days, and quite honestly, I think has turned out to be the best. So I had a VLNA, which simply means very low noise amplifier. It was the G4 DDK design that I built several years ago, if not 10 years ago. We did measure its gain and noise performance at Martlesham, and it was below 0.4 dB at 2.4 gigs. So that connects direct to the potty. We then have a bandpass filter after the LNA. Further amplification to bring the signal up to that which we need for the mini tuner, and I tried to achieve something like minus 50 dBm. And in this case, though, we have to use good quality coax back to the shack in order to minimize losses, because the signal now is at 2395 megahertz, not the 1500 that we had before. So here's the block diagram. Again, dish looking straight up, VLNA, and what I did actually is I had a short piece of coax coming from the LNA into a unit I called the filter amplifier unit. So in there I had the filter and the extra bit of amplification that I needed. And then I connected that box back to the shack, through the splitter again, into the mini tuner and the spectrum analyzer. Just to concentrate on the filter, now I bought this filter at Martlesham Microwave Round Table a long time ago, and it was marked up as being tuned to 2320 megahertz. So I retuned it, and it's quite easy to do using a nano VNA. So on the right we can see the plot. The insertion loss at the center is about 1.5 dBs. It's about 10 megahertz wide, and it has quite good roll off above and below the wanted frequency, which is just what we need to get rid of that potential interference. Okay, so I built the filter into a box with the 2 stages of amplification. You can see the silver box on the right is a small amplifier with a mimic, which I happen to have in the junk box, and similarly the amplifier at the back. In both cases, these devices were chosen to have quite a high output intercept in order to make sure they were relatively linear. There's quite a lot of gain in that box, and I did find initially that it oscillated. Guess what? And that was quite simple because I didn't have an attenuator connected to the output of the filter, which meant that outside of the passband I had a very poor return loss presented to the first stage of amplification. And it took umbrage at that and oscillated about 3.7 gigs. So 3 dB attenuator there cured that. I also added a small attenuator on the input to the filter to provide, again, better matching for the amplifier driving it. But in both cases, these attenuators help to maintain that nice filter pass band, because if you've got a highly reactive termination at either end, you can distort that pass band. Okay, so what was the filter's benefit? Now, on the left, you can see what I've got out of the coax into my shack. That's a snapshot. Center frequency is 2.4 gigs, and we're just a little bit below the center frequency at 2395. So the lower section of the to the left of the photograph is the 4G stuff. To the right is the mainly Wi-Fi. What it doesn't show there's the dynamic nature of the Wi-Fi, which can really go up and down quite a lot. Anyway, so that what I did was to loop out the filter to produce that, and then I put the filter back in, and I got what was on the right-hand side. Now, I had to alter the reference level on the right-hand side because the noise was off the bottom of the screen, so I moved it up 5 dB. And what we can see there is it seems to have wiped out that interference quite significantly. And I think that was shown later in the results that we had. So this is the latest fixed dish setup. Basically then the tripod, I had a vertical extension on the tripod, which was simply a die-cast box, which I then attached the filter amplifier unit that I described earlier. You can see the green coax going back to the shack. That is second-hand mobile telephone type stuff, 3.5 dBs over 10 meters, pretty good going. You could even use it up to 10 gigs actually. It's excellent cable. And the tripod is there to allow me to basically, if I don't want to do an overhead pass, because I realized actually I don't have to do overhead, all I need to do is point it at the maximum elevation and at the required azimuth, and I can cover lots of passes. So having that tripod arrangement allowed me to do that. So what did we get? Much better indeed. Successful reception, no dropouts thus far. I've done quite a lot of passes. I've got quite a collection. I videoed them, and due credit to my XYL, Joan 2E0HIZ, who actually did the videoing whilst I was pressing buttons on boxes to try and keep things under control. The ride locked within a few seconds of the carrier being above threshold, which is really good. And of course, as I mentioned, the tripod allows me a lot more flexibility in pointing the antenna. I tried to use it on the HAMTV downlink on the 18th. The 18th was an interesting day actually. That's a week ago. There were 3 passes. There were 2 passes early at my location, which were quite high elevation, of the order of 85 degrees, say. The first one, for some reason, wasn't used at all. It wasn't that early. It was probably about 8 o'clock in the morning, maybe a bit too early for the Cubs. The second pass, they put on a color bar signal, which was demodulated, no problem. And unfortunately, the third pass was at too low an elevation at my location to pick up reliably. And this is one of the problems that you have in an urban location when you're surrounded by houses, because frankly, you get blocked. So I'm always looking, I think, to have like a portable setup, that's why I've been looking at using the tripod. Okay, so here is a snapshot of that reception. The picture on the right, of course, is the spectrum looking pretty clean, and of course the color bars on the left. And I do have a video of this which shows how the signal evolves over a period of about 20 seconds. Now, what I think I'll do is I'll just step through the other slides and then we can show this video in a minute. So, conclusions on that. Okay, fixed pointed dish. Yeah, it gives you a chance to see the ISS without messing about with a positioner, and you can develop your receiving system with the full knowledge that when you get a positioner on there, at least you've fixed the RF part, perhaps. Using the S-band LMB, well, I gave a quick and dirty result, as I call it. May be suitable to some people if you don't have any interference, but frankly, I found it wasn't up to scratch personally. whereas the LNA plus filter gave very superior results. However, if we're going to use a tracking system, there are a number of factors we need to take into account. First of all, the link budget, and one of the problems we have here is that although we can get a very good margin at an overhead pass, for lower elevation passes, the actual distance increases significantly, and at say 10 degrees, you're 3.5 times the distance relative to an overhead pass, and that's going to give you an awful lot more free space loss. So that's going to eat into that margin that you've got, and for really low passes, you may need to think about a bigger dish. Thermal noise pickup, well, the antenna sitting looking vertically into space is the best thing that you can have. Hardly any noise, hopefully, going from space, but as soon as you start pointing the antenna towards the Earth, the side lobes start to pick up noise from structures and the ground and so on, and so the thermal noise pickup will increase, and that will also degrade the link budget slightly. And of course, we've then got the interference issue, which will be according to where you're pointing the antenna. You may be unlucky and be pointing at a local mobile phone mast, or maybe somebody's Wi-Fi, sorry. So that will be another factor which can come into it. Tracking. Well, I've been messing about with tracking systems for about the last 2 weeks, and slowly getting there. But the main thing I would say is make sure that it can handle the mass of your dish that you're trying to steer, and of course take into account any balancing requirements you might need. Tracking accuracy, of course, what do we need? I found that just within 2 or 3 degrees for an overhead system was quite adequate. However, if you wish to maintain every dB of your say link budget, then you may need to track to a finer point. And then we come down to the location of the receiving system, of course, and this is important. I mean, if you live on top of a hill and you've got all-round vision, brilliant, or perhaps a tall building. Unfortunately, most of us live in urban environments and we've got blockages and all sorts of stuff. So, you know, some of these things will limit our ability to receive the ISS, but I would say anyone, give it a try. Now, if I could say to David, if he could please play the video that I alluded to earlier, and this is the color bars signal that I sent to you.
Okay, here it is.
So what you can see is the basically the signal coming out of the noise. It will peak and then slowly die away, and with it, of course, we acquire the signal, the color bars, and then that disappears. Okay, you'll have to tell me when it's finished, but I can't actually see it.
Okay, yeah, it's just finished, Jen.
Okay,
back to you.
So there we are. That's it. I would say have a go. That's my taster for you. It's, I think, relatively straightforward to have a go at that. Once you've cracked the RF system, I would suggest that start looking at the position of thing, because that can be quite expensive and time consuming. It's mainly mechanical engineering in my opinion, and at the end of the day that can take us at least as much as time as you spent on the RF side. So that's it for me. Thank you very much.
Okay, Jen, thank you very much. I don't think we've got any specific questions for you. There's a bit of chat about other things, I think. Oh, actually, there is just one just come in from Dave, G8GKQ. Has she checked how much sun noise she gets from her dish?
Well, that's a good point, actually, because I haven't, and I should, because I did do a ground noise check at one point where basically I compared directly into space and ground, and there was a significant difference. But yes, I do need to do that, and because that is a standard reference check. Yeah.
Okay, I don't think I've got any other questions, but the good news is you're going to stay with us, aren't you, Jen, on the call, because in our final session for this afternoon, Phil Elm0 DMY is back with a presentation on receive filtering very shortly for HAMTV. And of course, you may like to join in with him towards the end of that presentation. So that's coming up very shortly. Thanks, Jen.
Yes.
and welcome back. Now for our final presentation of the day with Phil M0DNY, who's back to tell us about solving some of the challenges of adjacent band RFI on ham TV reception in the UK and examples of filtering to mitigate it. As I mentioned, Jen G4JIZ will also be on hand at the end to link these tips to her own experiments. So back to you, Phil.
Thank you very much. So I'm going to just cover again the standard setup, which actually you've seen from Jen as well. This is the LNA and filter afterwards that Jen ended up coming up with in her ground station. And we're mainly looking at the RFI, which again is the spectrum. So this dual issue of the 4G from 2350 to 2390 on the bottom, and then the Wi-Fi from 2.4 gigahertz up. It actually extends quite a bit off the end of the screen. But for the purpose of this presentation, I'm going to concentrate on this 100 megahertz span. So this is set to 100 megahertz span. And the main issue that I've found is that you end up needing quite a high dynamic range. And what that means is that later amplification stages can end up compressing and otherwise introducing non-linearity, at which point you'll both get a reduction in gain in the particular bandwidth that ham TV is in, and you can also start to see spectral leakage as well. So it'll look like there's signals coming up. If you're looking at the waterfall, it'll look like there's signals coming across where ham TV is meant to be. That's not actually happening, but that's your system overloading and not reacting as it should. I've put this system noise figure slide in again for anybody who didn't join us earlier. So in the system noise figure and optimizing the system noise figure, you end up needing quite a bit of gain to get over the losses that are potentially in your chain, particularly with a passive down converter. Like this ham it down system here, which has 12 dB conversion loss with no active gain, and so you end up needing a lot of gain in front of that to minimize your system noise figure, and that is where you can end up running into problems with that large amount of gain, not able to cope with the high power that you get through RFI. So I'm going to run through a couple of filters that I've been working with. So this is a 3-pole filter that I picked up, I think, at CAT25 that was being sold here. It's a 13 centimeter 2320 megahertz unit, and I've retuned that using the 3 tuning screws to center it on 2395. And there's the plot there. That's 100 megahertz wide. It's 5 dB per division. And I've put the spectrum squashed below for reference. And you can see that's quite nicely centered. The insertion loss was only 0.4 dB, which is rather nice. But it's also it doesn't reject very much. It's not doing very much, and it's not really doing enough in this case. So at this point, I was looking around for alternatives, and one of the issues that we've had is that we've had quite a few people asking us who had ham TV stations running in 2016, 2017. Okay, how do I build a successful ham TV station? What do I need to buy? And when we've gone, you need a good filter, they ask, where can we buy this from? And the answer is, search around at rallies for a few years and see if you can find one, which doesn't tend to be very popular. So Tim, MW0RUD, had been looking around for this same issue, and he'd found these Wi-Fi filters that are being sold on eBay and other low-cost outlets. And these are designed to protect Wi-Fi from other interference, but they have a lot of tuning screws on them. And he was looking into whether they could be retuned. He actually had one that he took along to CAT25 Part 1 and spent a while there on the SpecAn trying to retune it, and found that it was quite a time-consuming activity. But I figured as I have access to a SpecAn at home, I'd could spend a couple of evenings having a go at that. And so I got one to try myself. So here on the left is as it looked like disassembled when it arrived. So it's got the tuning screws, original tuning screws. Unfortunately, these have been hacksawed off. And so one of the first steps that Tim had to do, and I had to copy him on this, was to replace those tuning screws. So I found some brass tuning screws rather than steel, and inserted those instead. And then with calipers, I very carefully measured the exact exposed lengths of all the threads and attempted that to match as a starting point, the tuning. You can see in this filter, I don't actually have a plot of how it looked like before, but it was very sharp around the Wi-Fi band. It was actually quite decent out of the box before being used on Wi-Fi, quite impressive. And that's really down to the really quite well-designed, I wouldn't say precise, but well-calculated machining inside. So this is with the brass screws. This is post-tuning, and on the right is what I managed to do with it. So it's ended up quite sharp. This is again 5 dB per division vertical, 100 meg span. However, the machining that's done is obviously done to center it on the 2.4 gig Wi-Fi band, which is 2.4 up to quite a bit up, and bringing it down anywhere below 2.4 really added loss into it, presumably because the cavities aren't big enough. And so although I've got this quite sharp point nicely centered on 2395, I had nearly 8.5 dB of insertion loss. So it's not an ideal filter, but I decided was a good back pocket option to have, but you definitely wouldn't want to put this in front of your LNA. So in parallel to this, Graham Sherville, G3VZB, had been talking to John, G4ZTR, at Aerial Parts of Colchester, who I believe might be the manufacturer of the 3-pole that I have, as to whether he could provide any suitable filter for HAMTV. John regularly produces filters for the 13 centimeters band, and he was able to put together a small batch of filters designed for 2395 with the right cavity sizes for 2395, and we were able to buy those off him. And this is the measured result of the one that I received. So exactly the same scales as before. You can see it's tuned to have quite a wide passband, but it does roll off quite nicely, and at least reduces a lot of the high-end Wi-Fi and reduces at least half of the 4G that's there. One of the nice things about this is that the insertion loss, I think I've measured it at 0.8 dB there. I think actually it's probably closer to about 0.5, 0.6. So it is definitely an option to put in front of the LNA if you have to. We have had some stations that have had high gain LNAs, particularly some of the Kuna LNAs, are 60 dB of gain or such, which sounds great, but they overload very easily, and even putting a filter after it doesn't help with that. So this is a possible filter that you could put in front of the LNA. And as you saw, Jen, with her highly optimized system, was able to get 15 dB signal to noise. If this cuts it down to 14.5 peak, you've still got plenty of margin with that. So looking at the filter in place, the top screenshot is the SpecAn at my QTH. I am very lucky that I have no 4G locally. It's the only place I've found so far that doesn't have that 4G band, but I still do have the Wi-Fi to deal with. And the channel power within this, with no filter, was coming through my system at minus 30 dBm. And when I put that filter in, you can see that the height of the passband at 2395 in the center hasn't really changed. But with the filter in place, that was down at minus 48 dBm. So I had 18 dB less power coming through the chain, but still the same noise floor from the at the frequency of interest. And that was only with the Wi-Fi. I suspect that if the 4G was here, that would be improved by 3 or 4 dB. There'd be an extra 3 or 4 dB improvement within that as well. So I'm going to quickly run through what I had at the Warwick venue last weekend. So this is unfiltered. This is looking directly at the back of the LNA. From Specan on the left. This is the wider setup on the right. You can see the Specan perched on a box. And this was particularly looking in the direction of the west, where we're going to start to get the ISS rising over, and where we had less ground stations out in the west. We had more to the east. So this is where I wanted to try and optimize it, and there was a 4G tower roughly in that direction. So you can see quite a lot of noise coming in on the 4G, and this was causing issues. Particularly the Pluto was seeing seeing bouncing interference in the HAMTV band. A lot of this will probably be the Wi-Fi, as Jen mentioned, it's quite bursty. That adding to the power of the 4G adds together to make some high power bursts. So I put in the one filter, so this is John's filter, the 5-pole John's filter, and you can see that that's rounded it off quite well. In practice, for the low elevation that I was trying to achieve at this location, this wasn't quite enough, particularly looking at Warwick out towards the east. We had a line of sight out to Warwick, and the noise floor just came right up, looking in that direction. So I really wanted to try and lock this down. And so I also added that Wi-Fi filter in this case. And you can see that that's brought the noise floor down by about 8 dB, because I had that 8 dB insertion loss, but it's also really cut everything off quite nicely. On the right there, you can see the photo of the setup. So the blue cable is coming out through the dish, the boss of the dish from the LNA that's at the prime focus. It's then going into a 3 dB attenuator. This is to provide a good return loss, as Jen talked about, for stability for the LNA. I was a little worried this much power going into the blocking of the filter wasn't going to provide good impedance match to the LNA. So I've got 3 dB pad in there, then the first filter, then the second filter, and then that loops around into more amplification to bring it up to the right level for the mini tuner input. And this is the end of these slides. So if there's any questions, I'll be happy to answer them. If Jen has some input.
Indeed. Well, thank you. Thank you very much for that, Phil. Very interesting to see that adaptation of the local, the small, not the local, the little cheap Chinese-made filter there, converting it from Wi-Fi for this use. So really, really good stuff. And Jenna's joining you as well now, so maybe two of you can chat. I've just got one question, if I may, probably more for you, Phil, because you go to many of these ARIS contacts. Are the youngsters themselves interested in the technology? I can imagine that you sort of rope it off, certainly before the contact, but are there a lot of them interested in the actual technology used?
So we do get interest in the technology used. We do get them wanting to see the radios before the contact and have a look at what's going on. I do feel that the logistics of it sometimes means that we're often setting up at the weekend, for example, for a Monday morning contact or such, and that perhaps they don't get as much time as they should to talk to us about technology, to look at the technology and find out more. So we do get it a little, but I'm trying to cater for doing more in the future.
That would be nice, wouldn't it? But I can see how each contact is pretty unique, it sounds like. You know, you still have to do the homework for each one, even though you've done them for so long. Anyway, this is the last presentation, the formal presentation of the afternoon. So it's your last chance at home now to ask questions, either of Phil or Jen, who's still there. And plenty of opportunity to do that before we wrap up for CAT25 Part 2. So I'll just have a look here. I haven't got any questions as such. I've got a comment from G7LWT who says the LCOM Wi-Fi filters retune nicely for amateur use. They're not cheap, but they do come up on eBay from time to time. Any of you experienced with the LCOM filters?
Not personally.
No? Okay, well that's still a good recommendation. Thank you from G7 LWT. No other questions as such at the moment. Phil, you're the only person I've ever met in the world who's ever said that you haven't got 4G in your area and it's a great thing, because believe me in Norfolk it's not like that, and I think possibly other areas as well, but obviously that's helped you in that area.
Yeah, I mean I do have 4G coverage, it's just not this particular band. that's been rolled out yet.
I see. Okay.
I think yet is the key word there. As I said in the previous talk, they bought the spectrum in 2018. So in terms of the spectrum being available, it is quite recent. Perhaps they just haven't covered this area yet for that particular band.
But it's best to be prepared for it, especially if you're going to invest in all this equipment now.
Yes.
Jen, I guess you've been in touch with Phil and you've watched and looked at some of the articles and things he's written about this.
Absolutely. And also, I just want to say that with the advent of the HAMTV setup, I mean, it'd be nice if they could perhaps put a test card generator on there all the time instead of black video. That would be really useful. But it's an ideal topic to use during British Science Week, which is coming up in the new year, and to do demonstrations with schools or whatever, or scouting or cadet organisations. So I think that this ISS HAMTV is a really good boost and come just at the right moment.
Yeah, really good, and it makes it relevant. I'm sure most of you watching this will have heard of the term STEM, which is science, technology, engineering and maths, and it's a way of trying to make this technological world relevant to young people at school and college, you know, just to sort of make that real link between things. And it couldn't be anything much more cool, really, surely, than making contact with the space station. I mean, Jen's just made a good point there. Probably instead of sending out a blank raster, maybe they can set up a simple test card or something to say what it is, so that people could tune into it. What do you think, Phil? Is there a chance that you could persuade the powers that be to do that?
Yes, so there's actually been one in the pipeline for a while. I mentioned in the previous talk that we currently use this NTSC input on the camera, and they're holding on to the one remaining NTSC camera on board because the rest are HDMI. So ARIS has launched up to the ISS already a NTSC to HDMI converter, and inside this converter it also has the ability to produce a test card when there's no camera plugged in. So we are hoping that will soon be approved for use, and they will then be able to plug that in, and we should get a test card. I'm not aware of exactly what that test card involves, but at least it won't just be a black screen. And from my point of view in testing video players, I'm looking for the video players playing consistent frame rate, and at that point I just want to see some noise on the picture moving, something moving on the picture to show me there's still frame rate going on. So I understand that the ARIS team are working quite hard to get that through final approvals at the moment. There's lots of approvals it has to go through before it can be plugged into the power supply systems, checking it for RF compliance, all this kind of thing. And my understanding is that's going through the final stages, and we are expecting it to be plugged in the next few months, at which point that would be the standard to see, would be that test card instead of the blank screen.
Yeah, that'd be really good, wouldn't it? Jen, you're going to come back?
If I could just add something.
Absolutely,
there.
Please do.
One of the issues, I say issues, that one has come across is that occasionally the signal is actually turned off from the ISS, and they do this for operational reasons. Unfortunately, you know, if you're trying to receive the signal, you might say, is it my system or is it not transmitting? But what I do actually to check, I usually look at the ARIS website, and there's a whole collection of people trying to receive it. And if they can't receive it, then it's probably off, especially the Goonhilly site, because I use that as a reference station. And I say, well, if they haven't got it, I assume that it's on most of the time. At the moment, I know it's only a temporary feed. But having said that, you know, there's a whole bunch. If they aren't receiving it, that's what I say to people. If they haven't got it on there, it's probably turned off at the moment for good reasons. And they may be doing something at the ISS, which means they don't want the extra RF floating around. That's all I would say. Cheers.
Yeah, on that, we've got that does happen from time to time. They turn off the RF, as you said, particularly during spacewalks. They don't want all the transmitters switched on while they're clambering over them. But the other thing is that also the HAMTV unit is currently sharing a power supply with another science experiment on the station. And in particular, in September, there was a time where we were scheduled to hand over the power supply to them for just a couple of days. And their experiment ended up overrunning, I think due to some issues on their side, and we actually ended up off for 2 or 3 weeks. The best place to stay apprised of this really is the social media channels, particularly ARIS Intel or ARIS International on Twitter or Blue Sky. They really make efforts to be on the ball with announcing when things are going to turn off, when they're going to turn back on again, and also announcing when some plan has changed. There are a number of other status displays around which are not very well maintained. So the best place really is the social media channels. The merger page has been useful for the past couple of weeks. However, you'll see if you go to it this week, there's virtually no one on, because since the contact last weekend, we've all packed up the stations, and certainly I haven't unpacked mine from the boxes yet. So up to contacts, you'll see a lot of stations on there, but you can't really rely on it, unfortunately.
And may I ask, is the Goonhilly system generally switched on?
It is not, no. I had it on for several weeks in the lead up to the contact. I was quite lucky with the availability of it, and so I left it on and tracking. It is no longer on and tracking as of Sunday
so
last week.
that's, unfortunately, we can't rely on it as being saying that it's on. Okay, thanks, Phil.
Okay, we are getting to the end. If you have a question, this is the time you have to ask it, because otherwise we're nearly finished. I've got just one more question. Although, and I haven't given name checks out to many people now, but I've got to do this one because it's from Steph VK5FQ, who says, great show, broadcast here in Oz on 445.5 megahertz DVB-T. Well done. So there we are. So we are reaching far and wide. So Phil, or maybe either of you can answer this. This is from G4GXL. Is there a logical way to tune the Wi-Fi filter? Do you just adjust every screw in sequence and then repeat several times? Or is there a strategy for picking the sequence to use? I think, Phil, probably more for you.
So I went for each in sequence and moving it down. However, this is my first time seriously retuning a filter. So Jen might be able to help more on that.
There is a method which I forget the name of, but another way of looking at it, to get it in the right region, because sometimes you might have to actually tune it across quite a wide frequency, is to basically look at the input return loss and peak the cores from one end, if you like, looking at one end, terminate the other end, peak the cores at the frequency you're interested in for best return loss, turn it around and do it again. You'll have a pretty rough and ready pass band, which you can then fiddle a little bit with the cores to try and get it right. And it does take a little bit of messing about, I must admit. It took me quite a while to tune that filter to 10 megahertz width, because you end up with slope on one side or the other and so on. Anyway, but there is a method, I can't remember the name of it, shame on me, but there is an approach. So have a look on the web as the best approach to tuning multi-pole filters.
I think it's called, Mike has just come on and said it's called Dishal, I think.
Yeah, that's it, Dishal's method. So, Dishal's method.
And all this time later, Phil, as well, I've thought of the thing when you were talking about that spanner and the way it was. I think you were thinking of the word, or trying to think of the word protractor. Is that right?
I was actually thinking of plumb line.
Oh, plumb line. Yes.
But yes,
okay.
it was so that we could see against
the
a protractor.
Yes.
The protractor was written out on the back of a cardboard box that was mounted to the side of the tripod. Yeah.
Lovely.
It worked.
Well, brilliant. Thanks very much to both of you for this afternoon, and special thanks, I think, at time to say as well to the ARIS UK team who do everything they do. You're part of that, Phil, I know, but there's lots of people. We saw 2 or 3 in the pictures there, but there's clearly many more people involved with every one of those contacts. And I think we need to thank you both for what you do for ATV with that, but also what you do for all those young people, and hopefully inspire some of them to become the engineers of the future. So take this as a thanks from everybody, I'm sure, in BATC for all the work you do. But for now, for Jen and Phil, thank you very much.
Thank you.
Thank you.
And of course, thanks also to all of our other presenters today, as well as Studio Director Tammy M0TC, who's been working behind the scenes all day, making everything happen as and when it should. Maybe you'd like to show your hand, Tammy, to see you actually do exist. All right. All being well, we might come and do this again if AI hasn't taken over next time. But as mentioned in his address this morning, unfortunately, Gareth can't be with us to close this year's event. So after this short video, Dave G8GKQ will wrap up CAT25 Part 2. Bye-bye.
Well, what a day that was. Some really good presentations. I'd like to thank our presenters, Charles, for his overview of AI. It's good to hear from somebody who's been doing AI for so long and trying to apply it to amateur radio. I think I might wait another year before dipping my toe in. Justin, I was amazed at the level of integration you've achieved with that repeater, with the 3 repeaters there. Having designed the BATC ATV repeater controller, I know how complicated these things are, and you've just taken it to another level. So really impressive. Phil and Jen, well, Phil's presentation on HAMTV was a really marvelous summary of how we've got to where we are. And what struck me is, initially when HAMTV was going to be recommissioned, there was this sort of sense amongst some of us that we've all done it before. But what struck me is we've had to face new challenges with the new 4G band there, and pushing ourselves further to get continuous video coverage. Now, I think we're going to very soon reach the situation where the video coverage is far better than the VUHF voice. And Jen, the view of how to do it simply, that is exactly how I started with the 60 centimeter dish, hand steered, and I would encourage anybody to give it a try. And when the ISS is in high elevation, it is very loud, and the reward for seeing it is very great. So would encourage everybody to give that a try. I'd like to thank Gareth for putting the program together. I think we had a really good varied set of talks. But the biggest thanks of the day must go to Tammy and David for such a professional production. Really good to see such a high quality program, both in terms of video quality, presentation values, and presentation content go out today. So thanks very much to Tammy and David. And with that, I will close the proceedings for today. Hope to see you in person at CAT26 next year, which will be in early August. And again, online CAT26, online probably in mid to late October next year. So thank you very much for watching, and good afternoon.